Okay. So, yeah, you're talking about this one, right?
I actually also have a problem in week 7, but in week 8,
Uh-huh.
the question number 10, option number 3.
Question number three. Yeah. So, given
Option number 3, question number 10.
question number 10. Acha,
Option
two
number 3.
variables. Now, which of the following statements are correct? Oh, uh, uh, two variables in a base are conditionally independent if and only if they are d-separated. ठीक है,
If
slide.
I remember correctly, the professor said like the D separation is like the master theorem. Like
Ah,
if they are
yeah,
two
like
separate, yeah.
it's a statement in the slide itself. Two sets of nodes are independent if they are
No,
d-separated.
but yeah, but like the professor said something like this is the master thing. If you know they are D separate, they are independent. If they are independent, they are D separate. Something like that.
Mm-hmm.
And that's what
So
the
it's like
professor
A
is
implies
asking.
B, B implies A. So
Yeah,
it's like a double thing.
yeah, like
A
that's
double
what if and
implies
only if
B.
means 12, right?
There exists a unique Bayesian network that multiple can be constructed. That is fine. Two variables in Bayesian network are conditionally independent. Ah, if and only if might be the catch, na?
Yeah, that's the thing. Like the professor said, like the D separation is like the master thing. Like
Ah,
there's no better algorithm. There's no
see,
um.
the point that we might see here is, let's say if you have a Bayesian network like this. Okay, so I hope my screen is visible. Yeah.
Yes, yes, yes.
Okay. So तो कंडीशनल इंडिपेंडेंट में उसने इफ एंड ओनली इफ बोला है सो इफ दिस इज ए दिस इज बी एंड दे बोथ गो टू सी एनी इन एनी केस ए सो लाइक दिस डाइवर्जेंस रूल
It is taken into account by deep separation, right?
अच्छा एंड व्हाट इफ वी हैव अ डी हियर एंड इट इज नॉट इन द नेटवर्क
No, yeah, this taken account of D separation as well, because D information cannot from D to C. So D and C are independent, taken into account by D separation. Uh, uh,
बट आई थिंक दिस स्टेटमेंट दैट इफ एंड ओनली इफ दे आर डी सेपरेटेड
Sir, so can you give me an example where like like a Bayesian network where two nodes are actually independent but not D-separated? I don't think there is any example that is even possible.
सी the thing is that an undirected path. So there is no path, right? Two nodes are
Yeah, like
de-separated.
the
If
professor
every
said that if the information cannot flow between two nodes, then they are D-separated.
that flow is decided by a path, na? But if there is no path,
The information cannot flow and therefore they are D-separated.
but if there is no path, then the concept of de-separation itself is not applicable, no?
Yeah, but if there's no path, then you can say like they're already D-separated, right? The information cannot flow between them. I think the professor's statement is was specifically if the information between two nodes cannot flow, then they are de-separated. And if there is no path, then there is no possibility of information flow regardless of what you know and don't know. So they are obviously de-separated. I don't think there is an example of Bayesian net which you can give where two nodes are de-separated and are dependent. I don't think it's possible because that's the definition of
No, no.
de-separation
See
and
that
being
you are
independent.
saying the other way. See the statement goes like if and only if they are de-separated, right? So
Yes.
if even if they are not de-separated, they can be independent. So de-separation, the
How?
concept
Can you
comes,
give me example?
yeah. So like this one, right? There is no path between A and D itself. So they are independent, right? Conditionally बोलो नहीं बोलो वो independent है because information there is no path. See the concept of de-separation comes into play when there is a notion of path.
No, no, no. Professor said about the flow of information, not path. Even though this is
But
written
if
in the
you
slide.
read the slide, it says that two nodes are de-separated if every undirected path between them is cut off.
Yes.
And two sets of nodes are independent if they are de-separated. So that means two sets of nodes are independent if every undirected path between them is cut off. But what if there is no path?
I mean, like, I'm not like satisfied with this explanation because, like, if there is no path, they're obviously separated because information cannot flow.
Did you check the book about this? What does the book says? Is there any discussion in the book regarding this? I did not.
No, actually, I didn't even bother. I think it's obviously wrong. Oh,
Let me see. if we can jump to some that place. Mm, hmm. Problem solving, knowledge, logical agent, first order, classical planning, knowledge representation, Bayes rule, Bayes rule related.
Why not search for deseparation?
हाँ, ठीक है यहाँ पे हाँ वैसा वो भी कर ही सकते हैं राइट दी अच्छा इसमें है ही कंडीशनली इंडिपेंडेंट ठीक है देयर इज नो कंसेप्ट ऑफ डी सेपरेशन ओह इंटरेस्टिंग what it is searching or it is searching SCP. Actually, I think my argument would be that only कि वो if and only if बोल रहा है but what if there is no concept of path then what can you say I think that
I
would be
think if there is no path between them, they are obviously deseparated. I don't think the reason it's not written in slide because it's obvious.
let's see AI book ठीक है इसमें सर्च करते हैं हाँ there is a topological criterion called D-separation but अच्छा there is only one हाँ ठीक है
Sir, deseparation is given in the book at page number 437.
437
Hmm.
okay, but why can't I see that
437. It's
okay
even given in the appendix.
appendix it just mentions. So it says there is a general like if you can see my screen there, I opened the book itself. It says there is also a general topological criterion called D-separation for deciding whether given a third set Z. The criterion is rather complicated and is not needed for deriving the algorithm, so we omit it. Like that's what it is saying.
No, but they also discussed it in 437 a little bit. Okay, we have separate note. Actually, I have latest edition. That's why.
Oh, so which edition do you have?
I have the fourth global edition.
So can you share that? Like if that is fine with you.
Uh, I don't think I'm allowed to share it in the Google Meet. I can't share. I can't share.
Just so I
How
have
do I do
enabled
it?
it now. You can just do that for this one time so that we can have a look into. So what does it say? Either you can share it or
Oh
we can.
no, it okay.
I've given
Wait.
access. I've given
Present screen. Can you see?
yes,
Nice.
you can see.
There it says the most general conditional independence might be asked if base net is whether or not the conditionally independent of Y. Given third set D, this can be defined efficiently by base net to see whether D separation into an XML process the following. Considering the ancestral subgraph, consider X, Y, Z and their ancestor, add link between any unlinked pair of nodes that share a common child. Now we have the so-called mural graph. Replace all the directed with an undirected link. If Z blocks all the path between X and Y and the resulting graph, then D separates X and Y in that case. X is conditionally independent of Y given Z. Otherwise, the original base net does not require conditional independence. In brief, the D separation means the separation in undirected moralized ancestral subgraph. Applying the definition to the Bulgarian network, we can reduce the Bulgarian earthquake the independent given the empty set, and that they are not necessarily conditionally independent given around and the John calls and Mary calls.
Hmm. Yeah, but there also they are not saying a counter example like, yeah, this is a scenario in which. Scary, right? Yeah, you can stop sharing your screen, then I'll just pull up mine.
Hello.
Yeah, yeah.
Yeah. Sir, can you go to week 7?
Uh-huh. Just give me a minute. Week 7. Okay. Week
Question
7.
number 9.
Huh.
Yeah, this one is obviously wrong because there's an explicit graph drawn by the professor, where he explicitly says that FOL and BN are both not only ontologically different and also epistemologically different. It is in the slide by the professor.
See, so this
It is
one.
in the first lecture, last slide.
Okay. Let me see. I have that slide. Intro to AI, March.
Week 7. What was week 7?
This one, right?
Yeah. This slide. As you can see that FOPC, fact-based object and propositional logic are not only ontologically different but also epistemologically different.
No. Next again. FOPC and what is the other one? It is probabilistic propositional logic. Okay. Probabilistic propositional logic and propositional logic.
No, first order logic.
A first order logic is a subcategory of नहीं, first order predicate logic है वो.
FOPC. Fir-
FOPC is the first order predicate logic है वो.
and
Degree
what is first order
degree
logic?
degree that relation.
First order logic is obviously a subset of first order predicate logic, right? So first order predicate logic.
No, I saw this figure and I saw this line like this one and this one. Propositional logic, probabilistic propositional logic.
But propositional logic is not the first order logic. What is first order logic?
Mm, see, propositional logic.
Okay.
Correct? These are the questions. I don't want questions, man. Differentiation between propositional logic and first order logic. Concerned with the subset of declarative statements that can be classified. Facts about propositional logic. First order logic in which an extended part of PL. FOL articulates the natural language statements briefly. Another name for first order logic is predicate logic. In first order logic, we claim that the predicate and we say they are predicting some property of the object. If in the sky is blue, the predicate is blue and the object. So, first order logic is known as a powerful language. Unlike PL, FOL assumes some related to objects. FOL has two main key features, or you can say syntax and semantics. Technologist converts a complete sentence into a symbol and makes it logical, whereas in first order logic, creation of particular sentences will be made that involves relations constants. But what we studied was propositional. I think we studied propositional logics. We did not
I don't
study.
think professor actually went in depth in logic. He said like this is the prerequisite of the topic.
We studied propositional logic. Why then? Why are they asking about first order? Because I remember first order logic is very much
In
different.
the diagram, it is obvious like the first order logic is subset of that
Propositional
logic.
logic, no.
Yeah, in the diagram, like the
First order, first order
first order
predicate logic.
temporal logic and then first order probabilistic logic,
They are all. Uh,
and they're all subset of FOPC.
so
And FOPC is obviously different than the probabilistic propositional logic.
हाँ वो तो यहाँ पे है ना that is
And
here
both those,
that is
both
on the right.
ontology and epistemology. So first order logic should also be different in both epistemology and ontology. In the no,
So I think here they should not write first order logic. They should write propositional logic because we did not study propositional. We did not study first order logic. You see what is the difference? We studied propositional logic. Propositional logic converts a complete sentence into a symbol. That is what we have done. So unicorn is horned. We write it as H. We did not
hmm
write like is. So if so see if we were to write unicorn is horned in first order logic, so you know how will we write it? We will write it like this: there exists x such that unicorn x and horn x. Are we writing like this?
no,
This
we
is
are
a
not.
first order logic. This is a first order logic representation. But what we are indeed writing is that just h, that unicorn is horned.
Hmm.
Unicorn is mythical, we write M, but in first order logic, we will write like there exists X, unicorn X, and so not or and mythical X. This is how we will write it in first order logic. We studied propositional logic. This question, they should not ask about first order logic in the first place. You see, like it is saying right now that when first order logic, relation of a particular sentence will be made involves relations, constants, functions, and constants. You see, if you think about it, if you think about predicate propositional logic. Let me state like if you think about propositional logic and probabilistic propositional logic, so they have similar ontology, but they have different epistemology. Yeah, that is clearly described in the figure here. Which one? Yeah, here in the figure here, the first figure itself. I don't know why
No,
while writing the question they write like first order logic when you were not even taught first order logic. So you have just scratched the surface in logic. Like if you see lectures of other professors, you will find that logic is a very uh, uh, it's very much nuanced than what you have studied in this. This was just a very high level thing. What
Yes,
is
though I think the professor like said something like the logic is like the prerequisite to take this class. You should have already studied logic in your previous classes, and like, and as I'm assuming that you know this stuff, and I'm moving forward.
mm, yeah.
However, one thing I don't like is they didn't mention the prerequisites in the course outline like this exhaustively. Like suddenly we are talking about logic and like they didn't mention it in the prerequisites.
So are there any yeah,
Yeah,
I've written
they're
that.
data structure and probability, no logic.
Mm.
In this sucks if you like you just go blindly and you're like, oh my
But I
god.
think like hereafter also this Bayesian learning and everything would have been very hard for you guys if you don't know some basics about. Even here also when you were talking about machine learning aspect in constant satisfaction, and that part was also very heavy for you guys.
Yeah, exactly. It was heavy. Like that's why I said like that week was very difficult for me.
Uh, this week
The terms,
I felt very difficult this week. Like it was very uneasy for me these topics. But yeah, I read and it's fine. What are the doubts? Can we solve week 8 assignment? Yeah, we will start with that.
um,
Yeah, so in week 7, is there any other doubt? Since
no
you
sir,
already
I have the last year weeks a week doubt.
last
Let me see if
last to last years, इतना पुराना क्यों है?
because we don't have the last year because you were not available.
हाँ, but in
So we
week
said
8, अच्छा, for week 8 questions. So
yeah.
weekend,
No,
I
week eight,
was,
no, week sevens.
no,
Because
but
you were not available, so I like we were able to find last year question. This is the. Can you see the question, sir?
हाँ,
So in the network below, which of the following variables are conditionally independent given C? And the answer is said that B and E are independent. But obviously B and E are not independent because B and A are independent, which the questionnaire agrees with.
mm-hmm.
A questionnaire also agrees with A and D are independent. Questionnaire also says that D and E are dependent. If B and A are dependent, A and D are dependent, and D and E are dependent, then also B and E are also dependent because the information flows from B to A to D to E, obviously. And if the information can flow this way, then they are not independent.
So your problem is with B and A, or like what is your
I
problem?
think everything is dependent. I think all the four options are dependent. But the answer says like B and E are independent. But I think they're dependent.
Hmm.
Because given C, A and B are dependent. We know this
A
from
and
the
B are
diverging.
dependent. हाँ, ठीक है ना, वो तो
Given
divergent
C, A and
करो.
B are dependent.
Given
A and D
C,
are obviously dependent.
A and D are dependent, ठीक है.
And D and E are dependent.
D and E are
Yes,
dependent.
all are dependent by Marco's
And
rule.
yeah, of course, but because information can flow from one to other, right? If, the
हाँ, वो तो
dependency
see,
hold transitive
there
property.
is this path ना. See, only BCE path is blocked, but the other path BADC, BDACE path, that path is selected.
Yes, exactly.
That is what you are saying. So
Yeah.
given C, but I think in this iteration they updated it, na. Given C and D, I think.
No. Only not given D. Only C.
No, that is fine. So, but in I think in this week's assignment like they wrote C and D, right? Yeah, given
No,
C and
this is
D.
not this week's assignment.
That I know. That I know. It might be wrong. Like people can do mistakes, right? So
No,
it's
but they also wrote an explanation in their actually in 2021 as a solution. They actually gave an explanation to like what they were, how they were solutions, written solution.
Mhm.
Um,
I think he's just checking this. So we can also do a thought experiment like the one that professor used to do. So if it is saying C has happened, right, and you
mhm.
are talking about E is happening, so will it change the probability whether B has happened or not? So Based on the diagram that you showed, will it happen?
Of course, it will. Let's see. Let's make some concrete. Where was the? Yeah, here. Like for example, if A is let's say Bulgari, B is earthquake, C is alarm,
Hmm.
D is let's say earth news broadcast,
Hmm.
detecting if the earthquake happens, then the news will show broadcast, or and if earthquake happens, the alarm will ring, and
Hmm.
the alarm will ring if the Bulgari happens,
Hmm.
and the panic mode panic the E will panic if whether the news if the news comes about the earthquake or the alarm rings. Okay,
Hmm.
if we know that the alarm rung and we know that Bulgari happened, can we what if whether or not the probability of that the person will panic increase or decrease? Now if the Bulgari happen and the alarm ring, we can say that the probability of earthquake is reduced. If the probability of earthquake is reduced, then the probability of the news broadcast will be
Hmm.
reduced as well. And if the probability of news broadcast is reduced, but then the probability of panic will also reduce, even if the probability of panic increases because of the alarm. Therefore, it's what dependent on both D and C. And like in their official explanation, they say something like this. Question number, here where कहाँ गया? Question, what was the question number?
Oh, this is the logics.
The question number 7.
This is the logics thing, na?
Okay, week. What was the week, man?
This was week
8.
8. Yeah.
Yeah, question number. Okay, here's the explanation they give. A and D cannot be conditionally independent. So D is the direct cause of A. Of course, like I agree with this.
Mm-hmm.
B and E cannot be conditionally independent given C, since E is indirectly influenced by D. Of course,
Hmm.
B and E are conditionally independent, so information about B tells us nothing about E. This is of a false statement. Like, of course it does, because the information can flow through D.
So if we have E, but we don't have the entire Markov blanket, so it is not conditionally independent. And that I agree that uh, B and E are conditionally independent. Says information about B tells us nothing tells us nothing about E. They are connected through C, which is the evidence variable whose values are already given. But yeah, I see there is a path E D A C E also, E D A
Yeah,
C B also,
yeah.
not just B C E. But if you think so, if C is given to us, that means A and B are dependent. Hmm. वो उसमें इंफॉर्मेशन फ्लो हो जाएगा. If E increases, then D की कोई फर्क C has happened, E has happened, that means.
And B and E are independent. Is it like that? If C is given.
But if you
No,
check
their
the
question is asking whether or not B and E are independent given C is given.
if just C is given, then okay,
Yeah, this question is wrong.
just think about the deseparator. Okay, so what does the desepration rule tells?
These separation rules tell whether if the information flows
The
from one node to
desepration rule.
another, then they are
No, no, I'm talking about the cases. Like, let's be specific about the cases that we have in hand. Okay, so from BCE, that's not even like that. Let's talk in terms of the Markov blanket. I think that would be a much better approach here. So
okay. So
given
E's Markov blanket
uh,
is D and
given
C.
parents, X is independent of its non-descendants.
Right. So the parents are D and E.
The parents
We
नहीं
are
दिया
given
उसका.
C. We are not
हाँ, we
given
are
the
not
complete
given D,
Markov blanket.
not given D, ठीक है. तो
Yeah.
पेरेंट्स नहीं दिया है तो X is independent of its non-descendants. That statement is false कि
No, we
C
can't
is
say anything about
हाँ
that
हाँ
statement.
ठीक है. Now given Markov blanket, X is independent of all other nodes. ठीक
But
है.
we are not given Markov blanket.
Are we given Markov blanket? We are
No,
only
no.
given parent.
See,
Hmm.
We are not
But
given
not both the
parenting.
parents. We are only given
Yeah.
one parent. Huh, so that statement is false. Just simply rule it out. There is no point of confusion here. Because if you see in this week, in this week's iteration, they have updated this question. They have given both C and D.
No, this week attrition, they have completely changed the question.
No, no, they have kept the same graph. The graph is same. You can just see.
Yeah, but the question is completely different. Yeah,
No,
this right?
question is also the same. Like
No, the question is different.
if you see given C and D, E is conditionally independent of which variable? They have added D. I think that's what was the
No, it's
confusion
A,
last
na?
time. Hmm.
Okay. E is conditional dependent of
Given-
which variable, both A
Because we
and
now
B.
we have the parent, like we have the mark.
Yeah, they're contradicting themselves in the previous slide.
Yeah, yeah.
Yeah.
Now we have the entire Markov blanket, so it's fine. It works fine. Okay, so yeah, now you can unshare your screen and then we can start with this week's assignment.
Sir, previous week's question can be discussed.
Yeah, yeah. Week 8, na? Bayesian network, the one that was just shared.
Uh,
One question: do anyone have the link for solutions for week 8 or older weeks?
no, they don't give solutions, man. Though the
Acha, acha.
actual solutions are given in your SWAM, like when you are like marking MCQs, you will get answers after 12 p.m.
Ha. That's okay. I'm just like detailed analysis or questions. There is
No, they are
no
not
way,
given.
right?
They are not giving. No
Okay,
one's giving
okay,
that.
okay.
They were giving it in 2021, but from 2022 and 2023, they are not giving.
Oh, acha, okay.
So this is the graph that you have. Okay. So what is the first question that is asked? It is asking the minimum number of variables required to store the above Bayesian network. Okay. Minimum number of variables required to store the above Bayesian network. Hmm. So were you all able to crack this one?
I got this one.
Yes,
Okay.
yes, sir, it is okay. This can be found.
Yeah, you can
And
just.
for A and B, one variable each, and for
So
D,
it can be decomposed as P of A
and C has 4 and E
into
has 4.
P of B into P of C given B into P of D given A into P of E
I
given
think.
something like this, right? So 4 plus 2, 6. Did I do something wrong? Yeah, it is
You
D,
missed
D, D,
one. 4 plus
yeah, yeah,
4.
yeah, yeah. D comma C given. Yeah.
So this concept is actually those which node has only one parent, then it will have two variables. Similarly, those which do not have any parents, they can be represented using only one variable.
Hmm.
And the node which has two parents, they will
So
have four variables.
let
And then
us
you
write
can
this. Right?
just
We have P
write.
of A, B, C, D, E. Right. So how will we break this? Okay. So first, let us do P of E conditioned on everything A, B, C, and D. Okay. Now, if we know C and D, okay, that means it is independent of all the other variables. Right? That into P of A, B, C, and D. है ना? So this will be just P of A given CD. So this will take four variables.
Exactly, yes.
है ना? Then we have P of A, B, C, D. Okay. So this will be P of C, comma D conditioned on A, comma B into P of A, comma B.
That's a bit convoluted way to represent, but okay.
What happened?
I don't understand why you are making this equation. Like, can't we just count it be one
Yeah,
variable?
that we can always count, but I just want to get the entire probability, like
Yeah, but here, how are you getting into 12 number? Like, how are you approaching the solution?
huh,
Like P of E A B C D equal to P of C D because AB is not required, right? I mean, not
No, see,
directly.
for A you will need one variable, for B you will need one variable. So it will just store A. If you know A is with some probability, then you can always say negation A is with one minus
No,
this thing.
sir, how do you break this middle term? P of C comma D given A comma B. How do you break it? P of A comma B is fine. It is PA into PB
Huh,
because they are independent kind of thing.
huh.
But CD, how do you break this? The middle one?
That's what I'm thinking.
Mhm.
Okay, so then I should not break it like this. So C is just condition. C is conditioned on AB and D is conditioned on A. Okay, and then we have AB independently. So let me write this entire thing as P of. Let me write it like this, like P of A, B, C, and D. Okay. So from here we know that C is conditioned on A and B, and D is conditioned on A, just A. But C comma D given A, C given B, C given A comma B. Okay. So it can be. So if we know A, then D and C are conditionally independent. But we need to know E also. No? What is the property of diverging connection? Right?
Although if a diverging connection is simple, like if we know B, then we can say A and C are independent. D and C are independent.
But if information can flow between A and C if and only A, and we do have any evidence at B
That's
or B.
converging connection.
वो ठीक है. तो यहाँ पे so what will be the final expression? So did you guys try this expression में or
Uh,
did you?
no,
No,
no.
no,
Like
no,
I
no, sir.
just
This is,
calculated. We
yeah,
need one variable for A. We need one
yes,
variable for
हाँ,
B.
yes.
We
B
Two
need two
variables for
variables for
B.
D. We
variable.
need four variables for C,
Yes,
हाँ,
and we
exactly.
need four variables for E. The total comes out 12.
हाँ वो तो ठीक है but how will you write the expression?
I don't felt the need to write any
Yeah,
expression.
yeah. How did you reach to like C will take four variables? Like it
Because
is
C,
Because
dependent on A, B, and
there is
C, right?
I actually found a formula in the book. It says
Oh,
R to the
okay.
power P times 1 minus R gives the total number of required, total number of numbers required to denote the particular node. R to the
No,
power P times 1 minus R. R is the number of variables a particular node can restore.
but this is simple. Now, if C has
Yeah,
two
yeah.
parents
C
and each
has two
parent,
parents, so it
so
will
two
need four.
parents, so two variables mean you can have maximum four combinations. So that
It
way
should
you
be
get
actually
four.
R minus 1. Sorry. It's R minus 1, not 1 minus R. Yeah.
But even if you are so uh, R to the power P is the number of parents.
Yes. And R is the number of
R
variables.
is the number of values it
With,
can have.
yeah, exactly.
So it's like an max array, like array T or something. That is what was discussed. So if it can be like C, if C has only two values, which is C and not C, whereas if it was a weather, then it can be
No, no, sir. If a node has a single parent, then and if a particular node can take two variables, then if it has a single parent, it can take only two values. So that's how for D we have only two values. Similarly, C has two parents, so we can have four values. Similarly, for E, two parents are there, four values. You just go on adding, and A doesn't have any parents, so it's one. Similarly, for B, there is no parent, so it's only one variable, one probability you can
Yes,
have. That,
exactly.
that's the way I mean, I think it is to be done. Like, I don't know if you can
Yeah,
get an
that's right.
expression,
I
that's
think
fine.
it's right.
But
No,
Like you,
but D
and
has one parent only, right? How are you getting
no,
one?
no.
I mean,
A.
okay,
for
if
So
D.
D has
A
no
is
parent. D
true,
has no parent, so it can be represented only it will have only one probability, one value. That's PB.
Professor disconnected. Can you hear me? Am I disconnected or hello?
No, I think the professor got disconnected.
So what I'm asking is, like the formula you told, right? Uh, R to the power n into r minus one. So we have to sum it up for
Yes, you have
each
to
and every
find,
node,
you
right?
apply this formula to each node and then
Yeah,
sum it up.
And then sum it. Okay, okay, got it.
yeah, I am back. Hello.
Yeah,
Yeah, I
thanks.
think my connection dropped. I'm sorry for
Yeah.
that. Yeah, yeah, my connection dropped somehow. So, yeah. So I was just telling this thing that if you have to write the conditional probability table of E, then you need to consider all the variations of DC. So D comma C, D comma not C, not D comma C, and not D comma not C. Similarly, for D, since D is influenced only by A, so you need only like A and not A to store the values for D. For C, you need four for each permutation of A and B. So A comma not B, not B comma A, and not A comma not B. And for A and B, you just need to store the probability that they both are true.
Yeah,
The first
I
is
think I
just
think
being completed by adding one minus.
yeah, I think Gunjan, this is actually the explanation that we should have, right? So if we are dependent on two variables, means four combinations are required to completely translate it to the logic, right?
Huh,
So not A, not B, and A, not
huh,
B, B, not A, and A, B, right? So that will be the
huh.
logic. That will
So
be the
that's why we have, so see,
actual
for
explanation.
yeah,
Yeah.
so for E we have four, for C we have four, for D we have two, and for A and B we have one each. So 4 plus
One,
4,
one
8
each,
plus
right?
2,
Yeah.
10, 11, 12.
Yeah. So basically, it gets you the same formula, right? For R to the power P R minus one, something like that,
Uh-huh,
right?
huh. So
Basically.
yeah, I'm
Yeah.
just telling that this is
Yeah, yeah, yeah.
so the intuition
Sir,
behind
what
R to
is
the power
R
P
in
R
this
minus.
case? R to the power
Hmm.
P into R
So
minus
R
2. So
is
what is R in this case?
R is the number of
so R
values
is
by one
the
node.
number
Number
of
of
values
node.
you
I mean,
can.
how do you number of node? So in this case, it will
Number
be
of values in a node.
number of values.
We are
I
given
mean,
in the question
for
that the value is binary.
no, no. But in this particular case, what will be the value of R?
Uh,
Or you
Two.
are
two, two, because the question says that the value is binary.
okay.
So it can either be A or, so if it were three, then you need to say that D. So it will be like A B, A prime B, A double prime B. Then similarly for B, you will write like A B prime.
Oh yes,
So
that's
it will
also
be,
good.
you
Yes, yes.
understand, it will be these
Mhm.
many combinations A B
No, but
prime
this is
and then
also okay. R
A
to the
B
power P
double
R
prime.
minus 2.
R minus one, not R minus two. R minus one.
Two, man. We're not two, not two. Two is not coming anywhere.
R minus R minus one, right? It is R
R
Yes,
minus one.
yes.
minus 1. Yes, yes, that's also correct.
Okay. Yeah. Then the next question was, I think that we have already clarified that if C is conditionally independent of D given A, this is the only correct answer. C is conditionally independent of D given E. No. B is conditionally independent of A given C. No. Because if C was not there, then it is fine. But since C has now become the evidence, these two are no longer separated. And B is conditionally, oh sorry, B is conditionally independent of A given C, and B is conditionally independent of C given A. So that is again not a valid statement.
Yeah, Gunjan, one question here. So,
Uh-huh.
do we need to go through this deseparation route always, right? To get the question that x, if x is not dependent on y given z, do we always need to go through this disseparation route? Because if there are four combination, I need to check each combination, right? Is there a shortcut method in
So
anywhere?
you do not need to check all combination. You have to first check which case of the deseparation applies. So for example,
Okay.
C is conditionally independent of D given A. That is the scenario of divergence. So here, in this scenario, that you have A and you have so here you have, I think, C, and there was A D C. So these are the same. This is the same case here. So you have A and you have D and C. So if A is given, then D and C are conditionally independent. You might also consider E, but that convergence thing has evidence that if you do not have, then only information can flow. So here in the previous two cases it was do not, but here it is information can flow if and only if we do have evidence. So you need not consider that E. Or you can also think of this example where A is given as the parent relation, that if you are given parents, then it is independent of its non-descendants. So C and D are not non-descendants of each other. So that case can also be considered. Is it clear?
Yeah,
Or am
basically
I
the
wrong now?
disappearance, we have to check the disseparation rules, right? Each of the how
You
does
have
it
to check
apply?
which condition of the
Yes,
deseparation applies. That
applies,
is the
Yeah,
right?
only thing that
Mm.
you need to check.
So we have only three conditions, right, for disseparation, like
Huh. Huh.
yes, dear
mostly.
condition,
Mm.
convergence,
Mm.
divergence, and what's the third one?
Convergence, divergence, and linear.
And continuation.
These are the three conditions. So here in this scenario, when A was given and you are asked whether D and C are conditionally independent, you will apply the diverging scenario
This
and you
is
will get
divergence,
your
right?
answer.
Okay. Mm-hmm.
This is a divergent scenario.
Sir, in this case, given B and C are independent?
Given you can
Given,
so
No,
see
no. Given
they
B,
are dependent, right?
they
They
are
are dependent
dependent.
this
because if
is the
probability
linear,
of C
linear.
increases, then A also goes up. If C decreases, then A also goes down or something, because it is happening because of B only. So given B, C and A are there is no relation between C and A. They are still dependent. Like they are not independent.
No, no. Given C, B and E will be independent. No.
No,
No,
they are
we just
How?
now
dependent. Given
discussed that
C,
part, right?
B and E are dependent.
Similarly, given C and D, A and E will be independent.
No, given C and D, A
C
and
and
E
D,
are
C and E
independent.
will be independent. Yes.
Okay. Given C and D, A and E will be independent, right?
See, if C
But
is
B
given,
and
that
E
means,
will be dependent.
Yeah, B and A will be independent if given C.
Hmm.
see, if C and D is given, okay, so the path from A to E is blocked, path from A to E via D is blocked, A to E via C is blocked, and B to E via C is blocked, right? So, A and B is E is conditionally independent of both A and B, and vice versa.
Yeah, but can you come again? I mean, what did you just say? Like you want to
Essentially, what?
block C, right? Oh,
Yeah, so if you are given C and D both, right? So what all paths are blocked? Path from A to E is blocked. Path from A to E, so ADE is blocked. ACE is blocked, and BCE is blocked, right? So there is no way that information can flow from A to E and B to E. So they are conditionally independent. So E is conditionally independent of both A and B given D and C. That is essentially what I'm trying to say. Which was the third question?
Yes, sir. Sir, is there a I mean, what is the difference between simply independence, given something independence and given something conditionally independent? So in this case, obviously, uh, what's the third question, sir?
Third question, yeah. Given C and D, E is
Huh, A and
independent
E
of
are
both A
independent.
and B.
A and E are independent.
A and E, B and E both are independent. Like
But
E is independent of both A and B.
independent and conditionally independent. Is there any difference in this? I was thinking since conditional statement is
So
not there, so they will not be independent.
conditional is because you are given some evidence, na? So based on that evidence, you are
So is the
taking that
statement given C, D and E, sorry, given C and D, E is independent and given C and D, E is conditionally independent. Is
oh,
there any difference between these two statements?
I think
semantically
it
no,
depends on the
semantically no.
context.
Oh, it's fine. ठीक है.
Yeah, I think they should have said conditionally.
हाँ, ठीक है. Yes, you can apply
Yeah.
Markov
So.
bracket if C and D is given.
Mhm.
If C and D is
Yeah,
given, you can
Gunjan,
apply.
one question. Mhm.
हाँ हाँ.
Yeah. So one question is, so explanation for question 3, will it be like D and E, D and E, sorry, D and C separates E from A and B, right? So that will be the explanation for question 3. Is it like that?
No, no. C and D separates A and E and B and E. Or you can also use the
AB and E, right?
Markov logic of understanding.
AB and E, right?
If C
D
and
and
D are
C
given, so
separates.
A
Huh,
is condition.
huh.
A and B are not conditionally independent given C. That is what you have to understand. If C is given, then A and B are not conditionally independent. Only A and E and B and E are conditionally independent. So if you remember the scenario of John Call, Mary Call, so if alarm if see initially what burglary and earthquake were were independent, but as soon as the evidence that alarm has happened, right, burglary and earthquake became dependent. They were no longer independent. That's why I'm saying that only A and E and B and E these pairs are conditionally independent. Nothing else is independent.
A and E, right? A and E are independent, and B
B
and
and
E are
E are
independent, right?
independent.
Ha, ha,
But
ha.
A and B are not
Because
because you
because
know,
because C separates AB from E, right?
C separates A B from B.
Hmm. Right, right. Got it, got it.
Actually, it should be both C and D, not just C. C and D
Hmm, hmm,
both D
hmm.
separates E
Hmm,
from
hmm,
A B,
hmm, hmm.
not just
Because
C or
because
not just.
even if you deseparate C or D, it will go through the path. If D
Yeah,
deseparates, then it can go through C, right? And if
yeah,
C
exactly.
deseparates, it can go through D, right? So though both has to
Yeah,
be
this discussion we had
disconnected, right?
this discussion we already had some time back.
Okay.
I understand your point. That's true. So,
Yeah.
given both
Hmm,
C
hmm,
and
hmm.
D, A and
Hmm.
B are conditionally independent of E, or E is conditionally
Yeah,
independent
yeah.
of A and B.
Hmm, hmm. Got it.
The question number
Fifth
5.
one,
Yes, yes, fifth
fifth.
one. Question number 5th.
हाँ. So P of A comma B is P of A condition on B into P of B. This statement is true, right? P of A
Yeah,
comma
this is
B.
true.
So they have asked always true. Always hold means do you have to consider different situations to prove this? Because the second statement seems to be correct. But that's not
No, no, no.
correct.
Second statement
Second statement will be
is not
correct only when A and B are always
conditionally
independent.
independent.
Okay. Yeah,
Are
yeah, yeah,
independent.
yeah. So A is
See,
independent of C and B is independent of C. Then
can
only it
just
will be
apply
true. Otherwise, it will not be true.
formula of probability. Okay, you don't even need to go that far. So it is asking. So you see, you have P of A, comma B. Okay, so you can,
Mhm.
and you are given, you are asked P of A conditioned on B into B. So P of A conditioned on B into P of B. Okay. So what? How can you write this? You can write this expression as P of A comma B divided by P of B, and this
No,
as
no.
P
So,
of B. And
sir,
when you
can you
cancel
just
this,
expand this
the first
this statement? I mean, P of A comma B given C. Can you just expand and arrive at the result?
so if
I
you are writing P of A A comma B conditioned on C, you can just write this as P of A comma B comma C over P of C. So is this having to do when you multiply these terms?
No, no.
Sir, I'm sharing a link in the chat which gave an explanation to option number B and D.
D you can simply prove by proving the expression like LHS equals RHS kind of scenario. For that you don't need to bother. Like it's doable.
Yeah, so what's the problem,
See,
sir?
by the
Because if
whole we are
it
saying why second one is not correct. Why second one is not correct.
because if D is correct, then obviously B is not correct.
So that way, but if you expand A comma B given C, then it will be simply P of A comma B comma C divided by P of C. Then how do you proceed?
No, P of B comma
Hmm.
C. Okay, yeah, P of C, yeah.
Yeah. So how do you expand? Actually, I'm not getting. Is
And you
there any
write
Yeah,
limit?
you
P of
can't expand
Sorry,
A
because it is not
conditioned on
correct. If you expand,
no,
you
no,
will
no.
get option number
Actually,
D.
is there any material available on this? Can you
I
please?
shared it in the link. I shared it in the link. It proves that option number D is correct. And once you know that option number D is correct, then we can obviously say that option number B is false.
That's it. That is fine.
so see when will this formula hold when you can say that A. So if you write P of AC as I don't know constantly. Yeah.
Nima, what are you trying to say? Like, hello?
Actually, I lost my connection. No, what I'm saying is actually how to expand all these things because it is asking whether this statement is always correct or not. So, do you have to take different situations like independence conditions and then
No, no,
test?
no, 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 no. Like it's simple algebra. You can expand it via algebra, normal algebra. No need to take conditions.
Okay.
Okay, so if you want to like give explain like given a probability of A given B comma C is equals to probability of A given D, right? And we are assuming B comma C is D, which is equals to probability of A comma D upon probability of B. This is equivalent to probability of A comma B C upon probability of B comma C.
Hmm.
This will become probability of A B C upon probability of B C.
Yes, right. That's
Okay,
correct.
you're following here.
Hmm.
No issue. Now we will multiply both the denominator and numerator by probability of C.
Okay.
Now probability of A comma B comma C upon probability of C upon probability of B comma C upon probability of C. We are like just like
Okay. 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 Yes.
now we can convert this into probability of A comma B upon C by Bayes theorem.
Hmm.
And this becomes probability of A comma B upon C upon probability of B upon C. B given C.
Okay. I think that will okay. That will be okay. I can do
So
it.
like you had like notebook with you or something?
Uh, that I'll see. I think this is the way I can do. I'll be able to do.
Yeah, you just have to multiply both upon both
Mm-hmm.
denominator and numerator by
Okay.
probability of C, and you will be able to
Yes, yes.
calculate by Bayes theorem.
Yeah, so it is like P of B conditioned on C into uh, P of A comma P of A conditioned on B comma C, right? So this expression you can write as P of B comma C divided by P of C, and this expression you can write as P of A B C over P of B comma C. So this gets cancelled out, and so this then resolves to P of A comma B comma C over P of C. and this is equivalent to writing P of A,
A B given C.
A comma B given C. That. However, the previous one, which I was saying that C, P into P of B conditioned on C, this might not hold in what scenario? So see, P of multiplying P of A comma C into P of B comma C over P of C into P of C. Okay. Now let's suppose I assume that A is independent of C. Okay. And also A is independent of B. Okay. So then this A comma C, it can be split as P of A into P of C, right? Into P of B
Yes,
comma C,
exactly.
and then you can divide that, then resolves to P of A times P of B comma C divided by P of C. And since A is independent of both, so you can just, I think, group it together, P of A comma B comma C divided by P of. So only in this situation you can write it like that.
We are not given that probability of A and B, C is independent. So how can we
That will
do
not
that?
hold always. It will only
Yeah,
hold.
that's
Yes, yes, that is
Yeah,
what. So always
yeah.
statement means you cannot assume. Like,
I'm just telling you the scenario in this hold, so that's why
Yeah, that's why it says it will not
please
hold,
send link
right?
on the solution. Yeah.
So yeah.
Ha, ha, ha. Yeah, I'm not arguing that it is not correct. I'm just saying that
Mm.
I'm just talking about the
Uh,
scenarios in which it might be correct, but not always correct.
might be correct. Yeah, yeah. That's why the solution is not. I mean,
And you
it
just
it
prove
says
LHS
it
is
it
equal to
will
no
not
LHS.
not happen, right? Yeah, yeah. So
Always
that is
hold.
why
So
the
we
solution is
just
not
showed
even there, right?
mathematical,
So
and
yeah.
this one are always true. Hmm. Yeah. So let's first solve 7. So in above question,
one is dependent on 6, kind of.
yeah, asked P of C condition on D comma E, hidden variable. अच्छा okay. हाँ तो एविडेंस वेरिएबल तो डी ही हो गया एंड हिडन वेरिएबल आर ए बी सो ए बी डी मॉड्यूलो ए बी आंसर you guys were able to answer this, right?
Yeah, I only got one wrong.
yes,
Evidence
that's
variable followed by
that.
hidden variable. So
Hmm.
evidence variable is d comma I because that is given to you, and while expanding this formula comma b, so a comma b will be your hidden variables.
And which one is called a query variable? That means suppose P of probability of C given D and D. In this case, C is the query variable.
I
Huh.
think so. Yes.
Huh.
Okay.
That is true. Now, which one did you got wrong?
The which one I asked you, like the 10th question, option number C. If two variable is Bayesian
Yeah. So we
network are
will solve
conditionally
six.
independent.
We will solve the small ones and then we can tackle that. So I think you guys might have cracked this one also. So you toss a fair coin 3 times, given that you observe at least one head. What is the probability that you observe at least two heads? So it's just a simple case. If you toss 3 coins, this is what you can get. Tail, head, tail, 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 head, and tail, tail, tail. Yeah. So in 1, 2, 3, 4, 5, 6, 7 cases, you saw at least one head, and in 1, 2, 3, 4 cases, you saw two heads. So out of seven, four are your favorable cases. So 4 by 7 is the answer, and m plus n is 11. I hope you were able to solve this one. This was a fairly straightforward question. Yeah. And similarly in eighth,
So there's a question in the chat.
uh, yeah. What is the question? Sir, in question two, why B is not independent of C? Arey baba. Okay. In question two, why is huh? B influences C? So how can it be independent? Like
Like C is given, no?
in question two, is it stated that C is given? No, he's asking why is B
Oh,
independent of C? B independent of C is not a valid thing, right? Because B actually influences C. So if probability of C goes up, probability of B will go up. If C goes down, B will go
the
down.
parents are always dependent on their children, right?
So it cannot be. Sorry, A. So A also is a parent of C, na? Same thing. A is also a parent of C. See, your parents will always influence you. If your probability go up, the probability of parents will also like it will change proportionally to however your probability changes. That is how you judge the dependence thing. Is this still? Is it clear?
Mm.
Yes, sir. Okay. ठीक है. Now ninth one is done. Eighth one. Consider the following joint probability matrix. Each row contains a value for x, and each contains what is the
This one is
value?
forward as well.
Yeah, p of y equals to 2 given x equals to 2. So x is for rows. Okay. Yes, it will be 0.1 plus 0.15 plus 0.06, and y is to only 0.06. So yeah, it's just 0.06 divided by the entire thing.
Yeah.
So 6 over 21, which rounds off to 0.29. So yeah. You want me to solve this or it is fine? Anyway, I think it's just for the sake of internet, I can just do that. Yeah. So in this question, you are asked p of x y equals to 2 condition on uh, given that x is 2, right? So the scenarios in which x is 2, that sums up to 0.1 plus 0.05. So p of x equals to 2 is 0.1 plus 0.05 plus 0.06. So that is 0.21, right? And the scenarios in which y equals to 2 and x equals to 2, that is just 0.06, which is the last entry of this table. So p of y equals to 2 given x equals to 2 is just 0.06 over 0.21, which is 6 over 21, and this is approximately 0.29. Okay. Now comes the beast. Were you guys able to solve this question?
Sir, I didn't like even have to solve this question. I actually like with my future site, I was actually like I created a Python program and I just like ran it to see like 1 minute iteration.
You did the memorization thing.
Yeah, I rejection sampling thing.
Rejection
Okay, it
sample?
was qubit. Okay,
Sixth
what?
one. Sixth one. What are you talking about? I'm talking sixth
Yeah,
one.
yeah. I actually made like yeah. I'm talking about the sixth one. I created a Python program where four variables would influence the decision of each other, and I iterated over 1 million times, and I add one every time like this holds, and like counted like and added up and divided by the total number of time I iterated the loop, and I was able to get the answer 0.37.
Yeah, but did you try to solve it mathematically?
Yeah, I tried that as well. I got 0.37 that way as well.
Yeah, I think it was just so it can be just resolved to P of C comma D comma E, and then you will add A comma B, and you will put summation A comma B, right?
Yes,
And
yes, that's right.
then you will have alpha. And if you try expanding this, so I can write the formula for you. So it will be alpha.
Gunjan, actually, this one I tried. I mean, the same thing I tried, and this comes down to 0.02289. Okay, but the
Which
denominator, what will happen to the denominator?
which one comes down to 0.0289?
Like this value, 0.0289.
Acha. Okay. Yeah, so you can also try solving for P of D comma E, right? It will just P of D comma E.
Yeah, P of D comma E will be what? I mean,
So it
like
will be
sum of
I
summation
think you don't didn't
ABC, right?
normalize.
huh?
Acha,
I think the
no, no, no.
Arians
Here, I
didn't
think
normalize.
normalization is not required, is it?
Yeah, is it required? It is required. Normalizing is required
Oh, okay, okay.
Either you
because
do
you won't be able to
normalization
find the
or
value of alpha. If you normalize the
Hmm.
0.289, you will get 0.37.
Oh, is it? Oh,
Oh, this was
okay,
actually one
okay,
of the
okay.
steps like the professor did in his lecture. Like the
No, no, no. But
like
normalization is only when your denominator and numerator doesn't sum up to one. So there is no
yeah, it
denominator
doesn't.
here, right?
0.29 does not sum up to 1. 0.29, 0.29.
But how are you coming up to from 0.28029 to 2.37?
Yeah, the
Uh,
professor
Not
explained
getting.
the steps of normalization in his
Oh,
lecture.
okay. Okay,
You
okay.
so if you
can
if you just so this is exactly the example of John call Mary call. The graph is also exactly similar. So if you try following this, I think you will be able to get it. But yeah, I mean, I can solve this if you want. It is not that big a deal. Like you can.
just one more step. Yeah, this
Yeah.
is the normalization. Yeah,
So if you have this alpha times f3b and you just add this and divide by 1.
yeah. This thing is normalization, which professor did.
Yeah.
But here, before normalization, you should get the denominator, right?
No, no,
Like some.
denominator, you actually get two values by calculating negative and positive, and you see if they sum up to 1. If 0.29 if you get positive value of 0. You also have to calculate this negative 0, negative of whatever the question is asking, and you see if they sum up to 1.
Okay.
If they don't sum up to 1, then you normalize, and they don't sum up to 1. So you just
No, no,
didn't,
no.
you also forget, I
No,
think,
no,
to
no.
calculate the negative value.
No, no, no. Numerator is sum of A and B variables, right? What will be the denominator? That is what I think. What I ask. Okay.
No,
The
so
what
So
you
which is
the
basically
denominator can just be
Mhm.
alpha. You can just assume it to be alpha.
Oh, acha, is it? Okay.
वो अल्फा का पार्ट हो जाएगा ना because that is also that will be a constant value ultimately. So if you see this
Hmm.
example here also, when solving for b of j comma m, this p of j comma m went into alpha only. This entire thing, it was just normalized to alpha times pbjm. There was no computation for denominator.
Acha, okay. So that that is what I thought, because if you want to calculate denominator, it will be a huge sum. Okay, so sum of eight variables. Okay,
हाँ हाँ वो तो बहुत ह्यूज होगा
because
that.
you are summing over D and E, D A B and A B and C, right? And only
हम्म,
you are getting D and E as a running variable, right? Sorry, three variables running and two variables constant, right?
हम्म,
So it will be a huge sum.
हम्म.
So 0.00289, how are you achieving to that point,
So
like
this is
point three
point zero
seven?
two eight
Not
nine is
getting.
the probability of positive V, the V will happen. We'll also have to calculate the
Yeah.
probability of negative V.
Hmm.
And whatever that value is,
Oh,
say,
okay.
let's say positive is X and negative Y, the answer will be X upon X
Hmm.
plus Y.
Acha, negative B means negative A and negative B, or only
No,
negative
no,
B?
no. Negative B upon given condition D
So
and
in
E,
so
whatever
in
it
this
is.
example, see how you will open
Mhm.
up this how you will open up this. So you will just write
Uh-huh.
sigma a comma b, right? So you're
Mhm.
doing it over a comma b, and you have d p of d conditioned on c into p of e
Mhm.
conditioned on c into P
Right,
of
right.
C conditioned on A comma B into P of
Hmm.
A into P
A
of
into P of B, huh?
right. So
Right,
you can
right.
push this summation here, right? It will be
Hmm.
just P of D conditioned on C into P of E conditioned on C into sigma
Sum over this two
summation of
other
A
thing, right?
comma
Huh?
B, and then
Hmm.
you will write like P of C conditioned on A comma B into P of A into P of B. Now, while doing this calculation, you have to make sure that you do for both C and C bar. Here only you have considered C,
Okay. C and C bar. Okay.
or C naught, like not of C also.
Uh, mm,
If you do that in same expression, if you put not C, not C, not C, and then you get alpha 1, alpha 2, or like so P1 of this, P2 of this. So this will not add up to 1 directly.
mm,
For adding them up to 1, you take this alpha. So this alpha will be 1 over P1 plus P2, or something that sir has said, like the normalization
mm.
constant calculation that sir.
Normalization, basically, you have to add up to one, right?
Yeah. So you essentially divide it by 1 over 0.0019, like you did here.
Mm. Yeah, what he's saying in the comment is basically we have to do not of C and over D, right? So that is
Mhm. Mhm.
and basically X by X plus Y, right, right. Correct.
Mhm.
This is,
If this is
yeah.
P1, then the final probability will be
Yeah.
P1 divided by P1 plus P2 and P2 divided by P1 plus P2. So then you will get it.
Mm-hmm. Hmm. So basically, you have to calculate the alpha, right? So alpha doesn't come easily, right?
Now, alpha, these calculating P1, P2 is a bit of a pain.
Right. Yeah, I'll try that. Okay. Yeah, how it
Yeah,
goes.
if
Yeah.
you try filling this values, so you have to make sure that you consider both the cases, and then you just
Mm-hmm.
do that. If you are still not able to solve, if you follow this decomposition, and if you are still not able to solve, then I will definitely solve it in the next class. I have no problem doing that.
No. I
Sir,
think I think I think the way you did it and he commented in the um, chat. I mean, this makes sense. Yeah. Yes,
Yeah,
I'll try
and
solve that.
even if you have trouble doing it, you can just follow how the slide does. So in slide also that
Mm.
this entire thing was done. So here if you see,
Mm.
so this example is actually from here, the P of D conditioned on J comma M. Now you have to solve this entire thing. Alpha times PB, alpha times P probability of B into probability of E. Now here, even though the query variable was B, in final calculation, we do consider both B and not B. This is what you have to understand.
Yeah. Yeah. Got it. Got it.
And then once you got B, you can just say that, okay, probability of B happening is 0.37 or 0.27, whatever is the answer here.
sir, I wonder if can we apply one of those advanced variable algorithms taught in this week? Maybe we can get answer quicker.
Huh?
Like if we applied one of those advanced algorithm we are taught this week, like the professor, he taught like various tricks to solve these kind of problems in
Hmm.
in not NP hard,
Making
not
so inference in Bayesian network is a polynomial time thing, right? It is not. I don't think it's a exponential thing.
no, sir,
Making
it's
an inference
exponential.
from
It's exponential, sir. NP hard inference in multi-connected Bayesian network is NP hard.
but when we solve this one, optimal elimination ordering becomes NP hard. Identifying the right pair. Exponential is the largest factor. In eliminating, ordering greatly impacts the factor size. Complexity is linear in the number of variables. For example, three variable
Complexity
not
is linear if the graph is not cyclic.
cyclic.
One more, sir. Yeah. So one more thing, like the in the first lecture, professor created a cyclic graph of how okay, what does cyclic mean when there are like directional graph? If I say like A goes to B and B goes to C and C goes to A, is it cyclic? Or if I say A goes to both B and C and B goes to C, is it cyclic? Because professor
So
actually
you are
draw
saying A goes to B, B goes to C, and C goes to A.
this is
This is
cyclic,
what you
of
are
course.
saying. This is cyclic. Yes.
This is or and if A goes to B and A goes to C and B goes to C, is it cyclic?
A goes to B, B goes to C,
No, no,
and A
no.
goes to C.
A goes to C. Yes, yes.
And this is
Is
this is
it
not a
cyclic?
cycle. No, no,
No, no cyclic. Okay.
no.
Like the professor said,
If
in
this
these
was
kinds of
undirected,
graphs,
if this were undirected, then yes. But since you have given directed edges, right? So essentially, you are saying that A is influencing B, B is influencing C, and A is also influencing C.
these things are like exponential time.
These things are,
Exponential time.
ah. But in this case, it's like A is influencing B, B is influencing C, and C is influencing A. So
I think this is not valid.
then you cannot break out of the loop, or like there is no way you can eliminate variables or something. Then it might become a difficult problem. But yeah, I think if you try for both C and C naught, then I think you will definitely get the then you'll definitely get this P1 P2 and then alpha over 1 over P1 plus P2 LV. So I think this value was indeed I think it was something like 0.08 into 0.37, something like that. Or did I compute it wrong? I might have computed it wrong also. I don't know.
It was zero. Okay, it's exactly 0.37.
No. So what was just P of C that you are saying? Someone said no that they
0.28
can.
something. 0.28 something.
So can the same guy try doing that P of not C? What if we do P of not C? What will we get?
I
Okay, let's
actually
see.
have the
Yeah, zero
answer.
point zero two eight nine.
Yeah. So we have P of okay. So we have P of and then graph. No? Whatever is the graph. I always keep forgetting the graph. So we have D conditioned on C. Okay. So we have yeah. If we solve, let's try solving this expression. Okay. Into P of E conditioned on not C into sigma. So you also solved it like this, right? I hope this there is no confusion in this part at least.
Yeah, no, no,
Not
but there is no confusion. Right, right.
into P of B. Okay. So we know this value. Can anyone tell this value? What is P of D given not C? So let's solve this inside out. Let's not do first this. Ah. So we have this summation of A comma B sigma C A B E A B. So then we will do it for all the four variables. So not A, not B, not A B, A not B, and A B. Okay. So what is probability of not A and probability of not B? Let's copy this entire thing. Control C.
0.5 and 0.6. Right. Mm.
Yeah. So probability of A. So let us first compute this value. Right. So we have uh, probability of A, probability of B, that is 0.2, right? Into probability of, so I can also write like this, 0.5 into 0.4, and not C conditioned on A comma B. So not C conditioned on A comma B is 0.1, right? Then we have A comma not B. So A comma A comma not B, right? So this will be 0.5 into 0.6 into not C conditioned on A comma not B. So that will be this one 0.2. So this will be 0.8, right? And then we have not A B. So not A B, not A B will be so again 0.5 into 0.4, and C conditioned on not A B 0.5. So this value will be 0.5. I hope you are able to follow these calculations, right? Because these are very trivial calculations.
Yeah, yeah, yeah.
So 0.5 into 0.6 and P of not C conditioned on not A not B 0.1. So this will be 0.9. So 9 5 is a 40, 5 6 is a 30, 27. So this will be 0.27, 5 5 25 400, 8 5 40 24, and 4 5 is 20. So you add this up because you're doing summation. And
0.61, right?
हाँ मतलब दो दो चार दो दो चार दो छः और एक सात 0.81 why 0.6 or did I do it wrong? हम 25 400
Oh,
so
yeah, yeah. Point 81, right?
0.81, right? So we have, let me just erase this entire thing. Yeah, so we have, so I hope you are able to follow this calculation.
Yeah, yeah.
That is how you also did, right? You solved it. So you can correct
Yeah,
me
I
if I'm
solved the
wrong.
other part, but I didn't solve the not C part. So I
But
could have
like when you
do
solved
that.
for C, I hope you followed the same pattern, right?
Yeah, yeah. Same thing.
Or it was completely different than what I am doing.
No, no, no. Same.
Yeah, so this is zero.
Exactly same.
Yeah, so this part is
Yeah,
0.81, right? And then
yeah.
we have E given not C. So this is
And D given not
E
C, right?
given not C 0.4. Okay. And D given not C is 0.2. Okay.
0.2.
So this
Yeah.
is 248. What? D given not C 0.2, E given not C 0.4. So 2
Huh.
4 is a
Yeah.
8, 8 8 6 4. So zero point 0.6, 4, 4, 4. So 0.0648.
Hmm.
0.0648.
Yeah.
So one value you are saying that for C we got, what did we get?
0.0289.
0.0289. Okay.
0.0289. Yeah.
And for C naught, we are getting 0.0648. I hope this value is correct. You can cross check, but it was simple
Yeah,
math.
yeah, yeah. Hmm.
So now can you try like 0.289 divided by this value? What did you get?
No, but we have to sum. We have to sum these two. Point zero two eight nine divided by sum of 0.0289
Ha
plus
ha
point
ha.
zero zero
Ha.
six four eight, right?
So 0.289 divided by, then you add the
Sir, this
0.28.
gives 0.29, not the right answer.
Yeah, so that's what I'm saying. Is this value correct that you are
No,
saying?
sir, I don't think it is correct. It's giving the wrong answer. Let me check myself.
So
Uh-huh. Check it once.
you can check. Maybe I might have committed a mistake somewhere because these values are.
No, no, no. Your value is. I mean, you at least the calculation, the way you did the calculation is correct actually. So must not be any error. Okay. So maybe from my side, the way I have done here, maybe the value is a
We
bit
can we can just
higher,
do
so
that.
I
Like
cannot do.
I don't think it is that lengthy a calculation. So
Sir, the probability of not C comes to 0.0504, and probability of C comes to 0.0296. And when you normalize it,
Zero to
you
nine
get
that's
six.
what
You
I'm
said.
saying. I
0.37.
might have committed some mistake during calculation only, but yeah, 504 na.
Mm-hmm.
Okay, so let me type it here.
Mm-hmm.
Mm-hmm.
It is C given A or not A comma not B, D given C, D given not. So can you verify whether the calculation that I did was right or wrong? Can you make a comment on that?
I think it's obviously wrong because I got like a different answer than
Uh,
yours,
uh.
and
So what did I do wrong? Can you point that out?
I didn't like. I don't do such fair calculations, that I could like check like where it's my.
But you saw, right? Like,
Yeah,
But
I
actually,
can.
we got the point. We got the actual point how to solve this, right? At least.
no, actually no. If the values are wrong, then anyways it is wrong. So I did not solve it correctly. Let's not look at it like that. So P of B, A B E, not A B E, A comma not B E, and not A comma. Yeah. So here it is multiplying these three, and here it is multiplying these three. M given A, J given A, J given not A, M given not A. So this 9 7 63, sorry, 5 5 25, and 9 5 90. There is someone who wants to join. Okay, let's see. Admin.
Sir, the probability of that everything inside power P of A when we are calculating C comes down to 0.37. When we multiply it by P of A, it goes to 0.0296. And probability of minus C without calculating probability of A comes to 0.63. And when we multiply it by probability of A, it goes to 0.0504. And when we normalize these two probabilities, we get 0.37.
No, but how are you taking A out? Like,
We are just taking A common out. Probability of A comes out common.
mm, but this we have to do over all the values of A and B, right?
Yes, but we can calculate B and we can take A out, or vice versa.
I don't think that would be right or judicious to do, right? Because
Okay,
um,
I don't think I can share photos here, so I can't really.
let me see. If we are see here, we are doing calculation on A.
Yeah, let's see. Like he does too, right? He's taking probability of P common out of all that.
Hmm.
See, he's taking common out of two as well.
No, no. So no, no, my point is that here we are not. So here we are solving for C. Essentially we are solving for alarm. We are not solving for burglary. So this equation itself will not be the right one to consider. I'm just saying that you can follow how this has followed, but
But
like,
see, you can take things out. You can say like summation of on P of A, summation of
but then
B.
how will you consider this C conditioned on A comma B? Because C is conditioned on A and B, right?
Oh, C is common on both A and B, right? So it goes to the deepest stack.
Huh? That I understand, but see, they were able to take E out of this
Should
one.
I share my Jamboard? Maybe.
Yeah, I mean, if you can do that, if you want to, it's fine. P of E में से उसने E नहीं निकाला, A comma E, E बटा B और कर दिया, B डिपेंडेंस है नहीं, इसमें A वेरिएबल है, इसमें E वेरिएबल है. So this split itself is not clear to me. Like,
Okay,
why-
so
can you share your screen? I think your screen should be visible. Like,
okay,
from
you
my
can.
perspective.
Okay, I should share my screen, my task.
I said no. I think no, no, no. It's fine. I'll just open it. Did not share.
Okay, stop
But
sharing.
access denied. It says.
Let me share it. Okay. So can you see my screen?
Uh huh. Yes. Yes.
So we get probability of A. Okay, where's it? Sorry. Probability of alpha, probability of D given C,
Hmm.
probability of E given C,
Hmm.
summation of A, probability of A, summation of B, probability of B times, where do I write this?
Times probability of A comma B. That is fine.
Probability of C given
C
A.
given A comma B.
Okay. Now, now when you open this thing, like entire thing, this goes to. Uh, I'm just going to I'm just going to erase all things, and I'm just like keep in mind that this statement exists. Okay, like this is
Uh-huh.
going to get very messy very quickly.
Also, because there are lots of calculations coming up that I can
Yeah,
understand.
just like keep in mind that those statements are there, and if you open this, this goes to probability of A uh, uh,
C
times
condition on
no. I'm
probability.
just going to open all this thing,
Okay.
entire
ठीक है, ठीक
probability of C given AB plus probability of A, probability of not B, probability of C given not B,
comma A.
plus probability of no, where's comma?
C condition on A comma not
Okay,
B.
yeah, A comma not B, yeah. Probability of not A and the same thing
Probability of B.
and the same statement. Now we can actually take a lot of how to increase the size of the eraser.
That even I am struggling to do.
Like there has to be like some sort of button in Paint. I Control plus does, but
But
here it just
see, you got two addition terms with A, and then you will get two addition terms with not A. So essentially, you're adding four terms, right?
okay. But you can just take probability of a common, right?
Uh-huh.
And either you can
Probability
take
of A
probability of
common and
not a
probability.
common.
So that is what we did. So with A common, you will get two terms, right?
No, you get only okay. Yeah, you get two terms. You get two terms.
Yeah, B conditioned on A comma B. So essentially, we also added four terms. I think when we added, we might have multiplied it incorrectly or something. Because we also added these exactly four terms, if you remember.
I think you didn't. Did you multiply it by the statement where probability of D given C, probability of E given C?
That we
This
multiply anyways at the end, na? See.
this entire thing goes to 0.37, and when you multiply by probability of D given C and
Huh,
probability of E given
huh.
C, this goes
E
to
given C.
0.0296.
Hmm.
And if that the probability
Yeah.
and that's
See, if you yeah, that is so. I think. So if you remember what we also did four summations, and then you multiplied it by the probability of that. I think I might have committed mistake while calculating not C comma A comma B, like that part, because we also did four sums like the way you are doing. Ultimately, you are adding
uh,
four terms. Na? You see, one
uh,
with P A common and one with P not A common, but ultimately there are four terms that you are adding.
yeah, so it's probably a calculation mistake.
Yeah, I might have committed.
Yeah,
What?
it must be calculation only. There is no mistake. Looks like, I mean, yeah.
So you are getting 0.504.
No, this is 0.296 and
That is
0.37.
fine. What is the other one? What is the other one?
Okay, this entire thing goes to 0.63, and when you multiply it by probability of D given C, E given C, it goes to 0.0504.
Yeah, I think here I got 0.081, 0.81, so that might be incorrect.
And when you
That,
normalize these two state numbers, you get 0.37.
let me see if I can just do the calculation. I might have written some value wrong. That would be very probable with these kind of questions. But yeah, let's see. So I
Like
have
if even I actually, if this was the first time like in maths question, I was able to do it in like one go, but most of the time I have to like do it in 4 or 5 goes.
yeah, that I can
And
totally
even though
relate.
I was confident because it was 0.37 because I already calculated with the script, so I was like, okay, 0.37 is the right answer. Otherwise, it like in exam, it's going to be very hectic to do.
Hmm. 50 over 1000 is 0.03. 50 over 1000 is 0.03. Not a not a comma b is A not a comma B is 0.5 into 0.4, and P of C conditioned on not a comma B is 0.5. Yeah, so yeah, let me resume my presentation. If we can get this time right, let's. I don't know. Yeah. So 0.03, 0.5, 0.4, not C conditioned on not a comma B is 0.5. 5 5 is at 25, 25 4 is 100. So this is 0.1, right? And then A comma not B, A comma not B 0.2. So this will be 0.8. A comma not B, right? So 6 पंजे 30 अट्ठे 24 0.24 पंजे अच्छा पंजे 30 अट्ठे 24 240 divided by 0.24. Not a comma not b, not a comma not b is 0.1, so this will be 0.9, and 0.5 into 0.6. So 6 पंजे 30 30 ना 270, so 0.27. Yeah, what were you getting inside there?
For plus C, I was getting 0.37, not 27.
No, 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 no. This is for not C.
0.63 and 0.05404.
7 और 3 10, अभी भी नहीं 63 तो नहीं है, दो दो चार और एक पाँच.
Yeah, there's some mistake in here somewhere.
कहाँ गड़बड़ कर रहा हूँ मैं, मुझे भी नहीं समझ. A comma not B, A comma
No,
not
no,
B.
0.63 is possibly the whole calculation output, right? Like the
No, no.
denominator.
No, no, the whole calculation output 0.0504,
This
Acha,
part he's
okay.
saying that is 0.3. The
or at least some partial calculation is 0.63.
दो दो
Yeah,
चार.
yeah, yeah.
So this is 0.64 I'm getting or not. 7 और 3 10 है ना, 3 और 4 7 7 14. तो फिर मैंने गलती करी क्या, 6 5 30 20. This is a 30 27, 5 5 25 400 100, 6 5 30, 0.03. Not a not B is 0.5 0.6, and not C conditioned on not a not B. Not C conditioned on not a not B is 0.9. तो ये वैल्यू भी सही है. Not C conditioned on A comma B 0.1. Not C conditioned on not A comma B 0.5, and not C conditioned on A comma not B 0.2. A comma not B, A comma A comma B है 0.4 से मल्टीप्लाई करना था. 0.02. Now it is 0.63, right? दो
Okay,
चार छः
then
और
we
सात.
got it right.
Yeah, 0.63. हाँ, yeah, we got it, we got it.
Yeah, if
Our
only I had
calculation.
history in my calculator, I would
हम्म.
be able to show you exactly where you did go wrong.
हाँ हाँ, हो गया ना, 0.63 आ गया ना. यहाँ पे मैं 0.6 से मल्टीप्लाई कर रहा था, whereas I should be multiplying by 0.4. अब सही है ना, दो और चार 6 और 7 13, 3 2 2 4 5 6 0.63. Yeah, yeah, so now it is 0.0296 and 0.0 8 3 is 24, 8 6 is 48 50, 0.054. Now if you add this and divide, you will get 0.6 0.37. Redemption. Good. Is it clear now? I think I was just there was just this one mistake here. A comma B, it should be 0.4, not 0.6. ठीक है. Yeah, so this part is 0.63, and then we have 0.08, and the positive part was 0.0296. So now you divide, you will get 0.37. Is
Yeah.
it correct? Is it
Yes,
correct
sir.
now?
Yes, sir. That's fine. It's fine. Now it's fine.
Yeah.
Right.
ठीक.
Yeah, yeah. Thank you.
हाँ. Yeah, someone was asking in the chat. I think is that clear now? Someone asked in the chat, right? Can you solve this? I hope we did not confuse you even more. Whoever was asking.
I think the person who's asking left.
It's fine. Let it be. Okay. Yeah.
So after that, how we got point seven, please?
Rahul, are you trying to say
Yes, sir.
something?
Yes, sir. Yes.
Yes.
I understood what you have solved till 0.63 after addition.
Mm-hmm.
After that, will you please repeat how we got 0.37 as answer?
Yeah.
Actually, I
Okay.
lost my connection. I don't know.
Sure, sure. No worries. So, yeah, so up to this part is clear, right? So essentially, what we got
Yes.
as not, what is the probability of not C? The final probability is 0.2 into 0.4 into 0.63, right? So this value is 0.0504. Okay. The probability of C that was told by S name, it was 0.0296, right? Now we apply the normalization constant. So we want to see what is the P of C. So basically we will do 0.0296 divided by 0.0296 plus 0.0504. So this will be equal to 0.37. Is it clear now?
Okay. Yes, sir. I got.
Yeah. Yeah. And why we are doing this? Because the expression is alpha times something. So alpha times this entire thing will give you P of C conditioned on D comma E. So P of C conditioned on D comma E is alpha time this, and this alpha is equal to 1 over 0.054 plus 1. So this is 1 over 0.0504 plus 0.0296. So this is essentially your alpha. That is the normalization constant. And when you divide it, you will get the actual values for C and for not C. So this is 0.37 and this will be 0.63. Okay.
Yes.
Oh, sorry, not 6. 6 3. 3 7 plus. Okay. Right. So now coming to this week's part. So are there any queries, concerns in this week's assignment? First, let's talk about that. Because last time you told that you had some confusion in the assignment itself. Have you seen this week's question till now or no?
This is the first time I actually attended without actually checking the assignment first.
Nowadays. Okay. Actually, this week's is more or less on rejection sampling, and yeah. So what do we have? And that part of local agent, which I did not understand why it was with this part. So no, not this. This week 9.
Week 9 is mostly about introduction to decision theory and completing Bayes net.
Yeah. Yeah. So the first question, which of the following is true about map? It can be used without having any prior knowledge. That is totally wrong because you need some prior knowledge for estimating the map. That is the prior distribution of theta, and then it is equivalent to MLE with infinite data, and it is equivalent to maximum likelihood learning if P theta is independent of theta. So if you remember the expression of map was this. So in map, we do P of D given theta into P of theta, right? So if it is independent, if it is independent of theta, then it is equivalent to MLE. That statement holds true. And if you have infinite data, then you can obviously have some estimate of theta into calculation. So it also estimates to that of P theta. So it becomes MLE.
So
So
the
what facts are?
so the second one you said, right? I mean, if there is infinite amount of data, how do you consider it to be an MLE? Looks
So
like
then if you
there
have
is no dependence on the old data.
no. So if you have infinite amount of data, which usually you don't have, so if you have infinite amount of data, then you can then having a prior distribution of the parameter would not matter because if you have infinite amount of data, then you can
Hmm.
perfectly fit the curve, right?
हाँ अच्छा अच्छा got the
If we
basically
have
Yeah,
हाँ
which
infinite
is
fine.
amount of data, we
Hmm.
potentially don't have any test data, right?
yeah. So if you are
Yeah yeah
familiar
we
with
don't need the old one right. Yeah.
so if you are familiar with some concepts of machine learning, then you might have heard free lunch theorem, or you might go like
The
you
no
just
free lunch theorem, right?
no
The
free
no
lunch
free lunch.
no free lunch theorem. Yeah.
I didn't understand it. Can you like explain? Like I tried reading it, but
No,
it doesn't make sense to me.
so I also touched it briefly before seeing this list. So I think it goes something like if you have seen half, like if you have estimate of more than half of the data, then you can get then you can estimate the parameters with epsilon delta error. Like the probability that you will be off from the correct estimate would be infinitely small. But that goes to say that you cannot have such kind of data. So there is no free lunch. Like in no case you can have infinite data available to you. That is what the algorithm tries to say.
Hmm.
I don't exactly remember the word, but I know that interesting concept which you might like to go through,
Uh-huh.
to go over. Yeah,
Hmm.
this
Yeah.
is something food for thought kind of scenario. So, what facts are true about smoothing? Okay, the smooth estimates of. So, you guys remember smoothing, right? So, smoothing is a scenario in which, for some case, you were not able to find an estimate, and that value goes to zero. For example, here this value was zero. So, if you were to do p of a, not a conditioned on b comma e, you would say it is zero, right? But that is not correct. You should never do that. So here we do some sort of smoothing, such as add one smoothing. So we add one to all the values, and then we get the estimate of p of a given b comma a. So this that will now be amounted to 5 plus 5 plus 1 6, 6 divided by 7, which is 0.86. So something like this. So if you do smoothing, then what all can
So
you think?
where that seven comes from?
So this is 5 plus 1 6 and 6 plus 1 7, because this is now 1. Earlier it was 6 divided by 6.
Okay, so we're normalizing in this.
Yeah,
Okay.
yeah. So we are adding 1. We are adding 1. Normalizing, adding 1. Yeah. So this statement is obviously true. Smoothing allows us to account for data which was not seen in the evidence. The process of smoothing can be viewed as imposing a prior distribution over the set of parameters. So you have this you have so you are given the distribution, and then you are just adding one, so you are imposing some sort of parameter over that. And then smoothing is a form of regularization which prevents overfitting in Bayesian network. That part is also true, because if you did not do smoothing here, you will always overestimate that p of a conditioned on e comma b will always be 1, and p of not a conditioned on e comma b will be 0, which might not be true because you might not have seen the samples while doing your simulation. So you have to always account for scenarios in which you might not even encounter while doing the simulation, so that you don't overfit on the data that you see. So that's why smoothing allows you to account for data which was not seen in the evidence, and it also prevents you from overfitting. Yeah, question time. So you have this distribution, and this can be modeled as this Bayesian network. Assume that we have this. If the value of the parameter is m by n, such that m have no common factors, what is the value of m plus n? Assume add one smoothing. Okay, so you are asked to find the probability of not z given x comma not y, right? So first of all, let us identify the rows in which x comma not y holds, right? So x comma not y holds in these two rows, right? Here we see that one value is 1, one value is 0, right? So we do add one smoothing, right? So now it will become 1 plus 1 2, and this will become 1. Now it is asking for the scenario where it is not z given x comma not y. So essentially this row, right? So you will have 2 over 2 plus 1. So that will be 2 over 3. So P of not Z conditioned on x comma not y is 2 over 3. M is 2, y is M is true, n is 3. So M plus n is 5. That was just one example. Now comes the rejection
Uh,
sampling.
Sir, sorry to interrupt. Please
Now,
repeat question
yeah,
number 3.
okay. So should I solve on pen, or is it fine if I can solve it verbally also? Just let me do that.
Okay, sir.
Uh, yeah. अच्छा, वो बाप रे, ये वाला कौन सा है? And so we saw that there were two rows, right? Two rows of interest, essentially, x, y, z, where x was true and y was not true, and in yeah 1 0 1 0 0 1. Okay, 0 1. So this was 0 1, and this value had this instance was occurring only twice, and this instance occurred 0 times. So we do advanced smoothing, so we do 2 plus 1 and 0 plus 1. So the updated values are 3 and 2. Now you are given to estimate not z given x comma not y, right? So so this is 3 over 3 plus 2 also. uh, this was 1, not 2, sorry. Yeah, so this was 1. So 1 plus 1 is 2, right? So this will be 2 over 2 plus 1, that is 2 over 3. So this is your m, this is your n, and you were asked m plus n, so that is 5. Is it clear now?
Yes, sir.
So this was 1 and 0. So 1 plus 1, 2, 0 plus 1, 1, 2 over 2 plus 1, and you end up with 2 over 2 plus 1, which is 2 over 3. Okay. Yeah. So the next one, consider the following Bayesian network in which you wish to compute P of x given z using rejection sampling. Now, what is the probability that a sample would be rejected? So, can anyone make a guess? Like, what would be the way ahead here? So, let's say you sample something. Now you have to say that with what probability would you reject this sample, right? So, can you wager a guess when would a sample be rejected? If I ask you this, when would a sample be rejected? What will be your comment?
When z is not equal to what's given, that is false.
When z is false, right? So, what is the probability that z is false?
Probability that z is false, we are not given directly.
Mhm. So, can you estimate it? So, yeah, we can just do simple. So, it would be just p of not z conditioned on y into p of y conditioned on x into p of x, right? And then here we will do x comma y, because it is supposed to be like. So essentially it will be rejected when a sample is a negative sample, and for that we are estimating when a sample would be negative. So that for that we are calculating probability of not z, because only when it is negative we will reject that sample, and for doing that we will apply the simple p of not z comma x comma y and summation of x comma y, and we can write it like summation y p of not z conditioned on y times summation x p of not p of y conditioned on x into p of x, and if you solve this, then you will get it as 0.65, and that will be your answer. Do you want to solve this entirely, or you will be able to solve this? You can just let me know, because we have
I
done
think
a
it's
similar
it's it's
exercise.
clear. Yeah,
Yeah, we have done a
I
similar
think it's
exercise.
clear.
So it
Mm-hmm.
should not be that big a deal. Yeah. Now assume that we toss a coin with heads probability p 100 times, right? And we get head 66 times out of 100. If we are doing MLE estimate, and the MLE estimate of the parameter is m by n, so what is the value of m plus n, right? So we are given. So this is when we are doing for a single variable and we are given the scenario that is a coin toss. We will just apply the principle of counting to get the maximum likelihood estimate for the parameter, right? So it is given that you are tossing a coin 100 times. So we can only do. Okay. So this is not working anymore.
Why don't you just clear, like there's a clear frame button?
Ah, oh, nice. Yeah, that's a very good thing. Yeah. So we are given P, we have to estimate P, and we are given that out of 100 times, we saw head 66 times. So applying the principle of counting, we get P as 66 by 100. So this will be 33 by 50, and our answer is 33 plus 50, which is 83. Mm. This, yeah. Which of the following is suited for?
Where's the? Can you like scroll up a little?
So there was one. Now assume that we had a prior distribution over P as follows. Now we wish to compute the map estimate of P. Given P equals to M by N, where M and N don't have common factors, then what is the value of M plus N? So this is what you are given, the prior distribution, right? At 0.5 it is 2, at 1 it is 0, and something like this. So essentially we have to do the map estimate, right? Now what does map estimate says? Map estimate says that uh, maximize the probability of parameters after seeing the data, right? So argmax of theta, p of theta given d is argmax of theta, p of d given theta into p of theta, right? So we already know that it is 33 by 50 if we do by map. Now if you just multiply the value from here, the value that would be for 33 by 50, you'll get the answer as this is 166, so 83 by 84 or something, and then you can get the map estimate.
So multiply 33 by 50, right?
Hmm. So that
So wait a second. Can you like go from start?
let's not do that directly. Yeah, this question is saying that now we wish to compute the map estimate of P given P equals to M by N, where M and N don't have common factors, then what is the value of M plus N? And it is saying 167. Okay, so this is 167. Y equals to X minus. Actually, we need the value of a point estimate, but this is a continuous kind of scenario. It is not a discrete scenario.
That's what I was thinking
Have
as
they
well.
given it like this? This is I don't understand questions half of the time. Like either we can write it as a line equation, but I don't think they have drawn it to perfection. They have just drawn a triangle. They've just told that peak is at 0.5 and the value of that is 2. It isn't differentiable. It isn't differentiable here. That also becomes a
No,
problem.
it's not differentiable. It's not differentiable to 0.25.
Mm.
I don't think it can be solved with the method provided by the professor.
I
You
was
need
just
different.
thinking that if we do even like a simple line estimate, or if we try to estimate the equation of a line or something, and then just get the value of 0 point, so whatever we get at this 55 by to the 33 by 50, and then take
Why
up
is
the,
that matter? Why does 33 by 50 matters?
because that is what the MLE estimate gave you. So that, I'm
So
just
you are,
saying that I
yeah,
understand that we get
And
hit six.
is it like the value at 0 and value at 1 matters, right? Doesn't matter, right? The values are 0, right? Only the value at 1.5 is 2, right?
maybe we
So that
can
is
just take an average of this average weight of the triangle, half into base into height. That will go half times. that will goes 1 by
Half
2.
times half times half into 2,
So that will by 2
because it's a
1.
probability curve, right? It is a
No, no, 1 1.
half into base. So base is
Base
1,
into height. Base is
and
1 and height
height
is
is 2, and it should be
2.
1. So essentially, what you are doing is finding area under the curve, and there's a probability curve. So it has to be
And
1.
okay, okay, so it doesn't even matter.
So it will not matter. I'll have to see. I used to compute the map estimate B. So what I thought is, if you have an estimate of this line equation here, and then just take 55, like 33 over 50, and get the value there and multiply
Yeah,
that, you might get.
I can do a quick but I don't think it matters. But let's see if it solves the problem. It solves the problem.
Yeah, so
Um,
the equation of line will be y minus y1, which is, let's say, 0, equals to y2 minus y1. So that is 2 minus 0 over x2 minus x1. So that is 1 by 2 minus x1 is x1 is 1, right, into x minus 1. So y is equal to minus 4 times x minus 1, or y equals to 4 times 1 minus x, right? And if we feed 1 minus 33 over 50 here, what will we get? We will get 4 times. So what is 55 minus 30? It is 17 divided by 50. But I don't think we are anywhere close to. And this has crossed. So this is 34 by 25. That into 33 by 50.
that's
No,
1.36.
that has crossed, so that does not matter. Mm.
Like 34 plus 25 is equals to 59. The answer to this is 34 by 25, and that's equals to 59. That's not the answer.
No, 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 no. That is obviously not the answer. And so that is what I thought, that if you can have an estimate of a line, but now I'm thinking that it is not drawn to the sketch. Like, is it is it drawn to scale, or like, I don't understand why they make such vague questions. So see, if you want to compute a map estimate, then you have to find argmax of theta, which maximizes this function p of d given theta into p of theta, right? Now in your data, you have tossed the point 100 times, and you have seen head 66 times, and they have not even like, then it will.
What's theta in this formula?
Theta is p is theta, like you have to find
Probability. So we the
the
probability at which the data maximizes.
at which the probability of,
Probability of data given probability maximizes doesn't make sense.
no, data given theta. So
What's
theta
theta?
theta is the parameters that you have to optimize, or that you have to estimate. So essentially, argmax of theta given, or argmax of theta, so p of d given theta, that essentially tells you that you want to find such set of parameters such that your probability of seeing the data conditioned these parameters is maximum, so that you can estimate your data in a better sense. If you think of this equation p of d given theta, what it is telling you, it is telling you that given this parameter, how likely I am to see this data, right? And
Okay, okay, okay. I
if
see, I see, I see.
you have to pick that theta for which your estimation of your probability that you will see the data is highest. And that's why we're putting an argmax. Now, in general terms, what we do is, like, there is an equation. So we have this f of x, right, which tells you that, okay, this is your f of x, and if and when you differentiate it and set it to 0, you get the values at which it is maximum, and that is the maximum value. But here it is, they have not given proper equation of line. That's why I was just saying, if we do it like that. But if you take the even if you take the differentiation, it will just be the slope, which here is -4, which does not make any sense to me. So I saw some of the map estimates, like how to do that. So if you see, if you just simply search map estimates, so there they have this maximizing a priority distribution. A procedure is or not priority is their question. Yeah, this one. So there they say that your f of x is like this: 2x equals to 0 and 0 otherwise. Now you have to find the map estimate of x given y equals to 3. So we know that y is 3 conditioned on x equals to x, and then they have done something. This is a geometric series and so
What is
on.
geometry? Oh my God! Like this,
Oh, that is
this.
fine. You don't need to worry about that. So ultimately, what they do is they find this distribution p of y conditioned on x, y of x. So this is your prior, and then f of x conditioned on x, and then they differentiate it, and then they find the map estimate at that particular value,
So
right?
let's do this maybe. We know the function, right? We are given the function
But
x,
we are
x and
we are
minus x.
given a rough sketch of a function. That is a
Yeah,
problem.
yeah, yeah. But let's see if the answer works, then answer works.
Yeah, you can try, but we don't know from. Okay. We do know the distribution from which this data is sampled, right? So x is a point toss. So can you think of it like a Bernoulli thing? Because point tosses are normally considered as Bernoulli, right?
Yeah, but we don't know if it's weighted or
Yeah, because
biased or unbiased. But even then, we are not given that it's
yeah,
Bernoulli. Like
because
it does
we
not
don't know
have
the
the
nature
Bernoulli.
of distribution also. How y is sampled from x, or like how is data
Yeah,
sampled from the parameter.
yeah.
That also is quite unknown to us. That's why I kind of wanted to skip this, but it's fine. That question felt incomplete to me in a lot of sense. But it's fine. You wanted to have the discussion, so I went ahead with it. Or maybe there might be some solution in the archive that you can look it up, and then we can discuss it in the next class.
Okay,
So where are you
we
getting
are
these
not given
questions?
the archive solutions.
Where are you getting the questions that you were sharing in the first part of the lecture?
Actually, someone shared it with me, and like when I asked him how did he get me, he said like he was shared with someone else, and so on. So like this
So maybe
actual source. Was
you can what one thing you can do is try looking this question in the archive, you find it, and then we can discuss the solution next week.
No, sir, it's we only have for 2021. I will check if something
Ah,
similar
you
question
can
exists.
check.
And
Many of the questions are repeated many of the time, so
yeah, I will see in the 2021 archive
yeah,
if they have
check.
an explanation.
Because to me, this question feels incomplete because it is just given that we toss a biased coin, but it does not even tell that what sort of distribution is this following. Like we can assume that it can be Bernoulli's, but I'm not very sure that would that be the right thing to do.
Okay, let's skip then.
And these are the questions on global based agents. So a robot traversing through rough terrain to reach its destination without falling down. A reflex action to avoid hitting obstacles.
C
It is not
obviously.
suitable for a goal-based agent. Okay. So solving a Sudoku is obviously suitable. A destination without falling down is suitable. Algorithm redesigning an assembly line to reduce the amount of wastage as far as possible. So no. And a reflex
Why is
action.
the reflex action to like this should be solvable with goal-based action agent, right? Like
So
just
which
to
can
make the goal to not hit an obstacle. I understand that reducing wastage requires an optimization problem, but not hitting an obstacle is not an optimization problem.
No, I think here goal based means you only have one goal state where you achieve your success, right?
Yeah, like not hitting an
Possibly
obstacle is
solving,
one.
yes, for solving Sudoku, you have only one state which gives you correct answer, right? But obstacles, maybe there may be multiple
No, no,
obstacles,
no.
right?
That's not what the question is asking. The professor discussed the goal-based agent in his lecture, and he said like there are two types of agents: the goal-based agent and optimization agent. Optimization are
Mhm.
just more powerful version of the goal-based agent, which
Okay.
can like have quantitative reasoning as well as qualitative.
Okay.
ठीक है. So you are saying that a reflex action to avoid hitting obstacles, this can be solved by a goal-based agent.
Yes, make the goal to avoid collisions. That's
The
the
obstacles,
goal.
yes.
But it is saying that you have to take a possible action. You have to do a reflex action. It is not like you are just driving in a straight line and you have to avoid obstacles.
I
So
still
this
don't
is,
understand. Like, is the reflex part the key here?
yeah, the reflex action. So it's like, so it's not like you are just traveling in a straight line and there are some obstacles. So it's not like that you have to travel from like point A to point B and avoid obstacles that you find in the path. But instead, you are like standing and then an obstacle comes and you have to decide a reflex action. It can either be hit
Okay,
obstacle.
so the goal is something else. Like
Ah,
this is like the secondary objective. Like we
ah.
have to go somewhere. Like we have already have one goal, and this is like the
So
another goal to avoid obstacle.
I'm
Even
saying
then,
that
it can be possible.
I'm saying that if you were to travel like from point A to point B, and we saw these things, right? If you remember the simulations that you might have seen in A star algorithms or BFS DFS kinds of lecture, when sir showed some simulations that there are some points from which you can never escape, right? So that goal based agents were able to solve. But now I tell you that you have to do a reflex action. It's like you have to bend. You have to bend, or you have to like jump, or you have to, um or like you have to, let's say, so it can be any action, and your goal is to avoid hitting obstacles. So I don't think that part that can be solved by a goal-based agent. Like, is not suited. I'm not saying it cannot be solved, but it would be more suited for an optimization agent, right? Where you can set a reward thing that, okay, if you hit this obstacle, I will penalize you, but if you take the right action to dodge this obstacle, I will reward you. So the next time when you see that obstacle, it remembers that, okay, this is the action that I have to take because I was rewarded the highest in this scenario. So it can be modeled better as a goal, as an optimization problem. So this is I think a very standard use case for reinforcement learning, right? Robotics. So if you kick it, or like if you throw a log on it, it knows how to bend down, it knows when to jump, so things like that. It can be modeled better. It is not saying that it cannot be solved by, it is saying it is not suited for a goal based
Okay,
agent.
the suited may be the keyword here.
Suited for, not solved, it is suited for. So this is more suited for a optimization agent. And that, I think if you know about reinforcement learning or like the concepts of robotics or something, then you might know that this is a very common problem. Like if a robot is walking and it sees a log in the road, so it can like what to do, jump on it, or like just not go ahead. So these are all the actions that it can do, right? And using reinforcement learning, you can reinforce a positive behavior when it takes a correct action.
So that means it is a optimization isn't based, I mean, reflex action to avoid hitting obstacles or algorithmically designing an assembly line. Both are optimization based.
Because it says redesign, algorithmically redesigning an assembly line. So, how to decide when to redesign, or like what redesigning action to take? It would be
Yeah, these are all
easier to model as an
optimization based.
optimization problem.
Hmm. And solving
Then
Sudoku is a normal problem. So it is
solving
a goal
Sudoku is like
based.
is like there is a goal state that you have to reach, and you can
Similarly, the
easily
first
traverse.
option is also a goal based, is it?
Yes. So this you can also do like a constraint satisfaction, which the constraint is that you don't have to fall down, and your goal is to reach to the
Yeah, but
destination.
the professor also told that the constraint satisfaction and the optimization problems are interchangeable, and there is no real difference between them.
I'm just saying that the statement is not suited. It is not solvable by. That is
Oh,
that is my point of view. That it just says not suited. It does not say that is not solvable by, or because that would be a much harder claim to impose, like to verify or to impose. I would rather not say not solvable, but I would just argue that, okay, of these four, I think these two are much more suited for goal based, and these two are not suited for goal based. It is better if you solve it using some optimization based agent. That is my point of view. Yeah, and so which of the following are true? Rejection sampling is very wasteful when the probability of getting the evidence in the sample is very low. So I think you will agree with this, right? Because if it is very low, then you will be rejecting most of the samples. So it is very wasteful in that sense. And this MCMC thing you can verify from the lectures. So we perform conditional probability weighing on samples while doing Gibbs sampling in MCMC algorithm, and we already have fixed evidence variable. We perform random walk while sampling. This statement I have not even heard.
No, the random was not even discussed in this
Yeah,
context. This is obviously false.
this is obviously false. Likelihood weighting functions. Functions
This is
well
wrong as
given
well.
many evidence wars with some samples having.
We should always avoid having nearly 1 or 0 probability.
Hmm, hmm.
Right.
Yeah, I think like I feel the previous year's questions were easier if you have gone through the lectures.
Yeah,
That's what
I'm saying same. I'm the saying. I said the same
because
thing.
all these concepts were clearly discussed in the lecture. Like there was not a single point which was not covered. Consider the Bayesian network. Which of the following options are true? P of C, A, B, D, F, E. Okay, it is just C. So C conditioned on A and C conditioned on B. So that is obviously false.
It should be D as well, right? Children's matter as well.
No, no. So it is splitting on A and B, where it should be A comma B, right? It should not do A.
Okay, yes. It's going to be A, comma B and D, right?
D D evidence में now still it is fine. Na? See, it's like estimating the probability of alarm given Bulgarian earthquake. So do you need John call for that? No.
Because John call affects the alarm, right? If you know John called, we can assume we can have
See,
some inference about
you can
probability
you
of
can
alarm
put
going off.
you can put the entire thing into constant. So it's like uh, alpha times P C
I'm just
condition
saying
on.
probability of C given A, B, C, D, E, F, E cannot possibly not have D in this because D affects C.
Only if it is present as the evidence. See, if you are estimating, if you are see, I am only dependent on my parents, right?
No, you're also dependent on the children's.
When estimating the probability,
Yes, like the
not when
professor
if
explicitly
it is
says that you are dependent on your parents and the children's of your parents. No. The children's. Okay, what was that? Other children's of their parents, of the other parents of your children's. Yeah.
let me open the slides, otherwise we'll just it was March 17th. Yeah, this one. इसमें what it is saying. So you
Okay,
are
so this
saying
agrees
that
with me. This agrees with me.
hmm,
I'm saying B is wrong.
no, but yeah. But what I am saying that while estimating the probability of C, it's not necessary that you have D in the evidence.
I think it is necessary.
But if you see this answer is accepted, right? Here D is
But the
not in the
last
evidence.
one,
So D is not in the
probability of
evidence here.
D given C and E. Okay, this one is okay. This one's confusing. If you like try to break it down using standard rule from chain theorem, it will goes probability of C given A, B, C, D, E, F, E, and we can remove Fe because it is independent, right?
We can
And it will
remove
go
also.
probability of C given AB. Then we
Hmm.
can say probability of B given D, F, E, and probability of DFE are all independent. We can just remove that, and then we'll go probability of D given FE. right?
Probability of D
Like
given
you
F
why
is.
not apply chain theorem
हाँ
here?
हाँ see that is we can do, but it is just asking that okay, you just see the graph and you just tell me that whether I can factorize it as this or not, and I can put the rest of the things in normalization constant. Let's not go there. But just writing A B, but like A B D and E, here D and E I have to keep, F I can ignore, because F is C is not dependent on F.
Yeah, but you were saying B is right, right?
No,
Or
I'm
B
not
is
saying
not.
B is right. I am saying that I can write it like this, but I'm not saying it is right. I'm just saying that having D on C conditioned on A, B, D, that is not necessary. I'm not saying that B is right. You are saying that D needs to be in the evidence list, so I'm
I
saying that
think
no,
like
it's not.
because
It
D
won't be
D
necessary.
affects C, right? If let's say if C probability of alarm given Bulgari earthquake, John calls, Mary calls. I
Hmm.
don't think you can just skip the Mary calls and John calls.
No, but what I'm saying that alarm given John calls will not be a valid attribute there. How do you split that probability network? You split it as probability of alarm, probability of John calls given alarm, Mary given alarm, probability of alarm given burglary and earthquake into probability of earthquake into probability of burglary.
Yeah,
You
that
don't
was
write
because
you don't write probability of alarm conditioned on burglary, earthquake, and John calls.
the
Do you write it like that? If you don't write it, then why would you write D here? That is what I'm trying to argue.
like, but if you write it, then B should be right as well.
I'm not saying B is right
No, no,
because it is
but if
incomplete. It
if
is
that is
incomplete.
right, then you can push everything else in the alpha, and B should be right.
No, no, I'm not saying that it is true, because you need to account for other variables also, which this one did. D conditioned on C comma E. See, I cannot remove the entire thing here. I cannot write just A B, because I know that D is true, and I know that I have some evidence on E and F, right? So then this then then the dependency point becomes valid. That's why just writing this will not be true. You also need to have some information on DNA to make this thing complete. See, if you see the rules, like here, I think this is a so given E and D, what is that? Where is that? Ah, diverging, diverging, deseparation. So information can flow between A and C. Information can flow between A and C, can only not have evidence at B. तो ठीक है. So did you try breaking this up?
Breaking this up, obviously, like if you break it up with chain rule, then things get messy. Like it doesn't even follow.
And what are we have P of. Let's try this. Now what's the harm? Either we will find a solution or we will not find a solution. Okay. So now what are you saying? What is your claim?
I think the option number D should be right, and I don't know about option number C. Option number D is obviously right. These are in the Markov blanket. A,
तो
B,
ए
D,
पी
and
बी
C.
ए होना चाहिए. ठीक है.
होना चाहिए. But I don't understand why the option number C is right.
Sir, if we expand using that chain rule, then we might get this option C.
The
We have
chain
to
rule
expand
gets
it.
crazy. The chain rule gets crazy. I tried, and I already have seven terms at my hand. I can't even.
नहीं नहीं वो वैसा मत करो. See, what are the evidences that we have? So we have A, B, D, F, and E. ठीक है.
So that
So
can be written as
so
P,
see,
C,
is C
A.
conditionally? So let us think that is C dependent on F?
Is C dependent on F given B, A, and D, and E? No.
No, right? So we can remove.
Given if we are given
So
Markov
given
blanket
B,
F,
C, and F will be dependent, na?
given other values, it is not dependent on F.
Information can flow if and only if we do
No,
not
no,
have
but
any evidence, right?
no. We don't have to even talk about D separation. Those form the Markov blanket. D, and E form the
Okay.
Markov blanket.
If we know the Markov blanket, then it is independent of all the other variables, right?
Yes,
So that means we
uh,
need to write P of C conditioned on A, B, D, and
D
E.
and E.
That is
Right.
its Markov blanket, right? So Markov blanket includes parent, child, and
Children
parents
and
of child.
parents of your children.
Parents of your children. Yeah, exactly. Let me see once more. What do we have? We have Markov blanket X as parents of X, union childs of X, union parents of childs of X. Okay? So that means E, A, B, and D are given. So C is independent of F. That part is clear. So that we removed. So this option is true. Option number D is true.
Hmm.
Now let us think why this might also be true. P of C conditioned on A comma B into D conditioned on C comma A. Okay, so what is? Let me just copy that expression. Do you think this will also be true? Let's see. Control C. Did not do. What will happen here? So C conditioned on A B and D conditioned on C E. So if I write this, I'm putting an alpha also here. It will be P of C comma A comma B divided by P of A comma B into P of C D E divided by P of C comma E. Right? So then I have to somehow get P of C condition. This is alpha times something. So alpha times you point that how can I take this up? When you have C condition on A. So C is dependent on A and B, and D is dependent on C and E. C A B into P of C A B into P of C A B condition. So did you apply chain rule here? What did it give? Did you try applying chain rule?
Oh, I actually forgot. Actually, you can't apply chain rule here. You can only apply chain rule before it was A, B, C, D, E, F. You can't apply chain rule on conditional probability of C given A, B, C, D. You can't apply that.
You have to break it down. Yeah, break it down. So even if you write it like this, na, it will be P of A, B, C, D, E, and F, right? And alpha times this because we will just let go of the denominator. Then I can write it as P of C conditioned on A comma B, and the remaining thing will be probability of.
No, sir, you can't do that. It should be C upon all the probability A, B, C, D, E, F. Then you can move to other variable and lose C. You can't go C upon given A, B.
No, no, if what is the harm if I write like this?
Is it valid? I don't know. I don't think so. That's not chain rule.
No, no. See, what I am doing is, I understand that A, B, C, D, E, F. I wrote it like P of C conditioned on A comma B. But not let's do like this.
This is not valid. This is not valid.
P of D conditioned on C comma E into P of C conditioned on A, B. That alpha can be normalization constant, na? A, B, uh, F and E, right? A, B, F and E, right?
Whatever this is, it is not chain rule.
No, no. See, I'm skipping some parts here and there, so try to understand this. Essentially, what I am skipping is, अच्छा, let's go the other way around. Okay, what are we given? Let us first. So we are given C condition on A, B, D, and E, right? What are we asked? A, B, D, F, and E. Okay. Okay. So we are asked A, B, D, F, and E. That is what we are asked. Size बड़ा हो जाता थोड़ा सा अच्छा रहता. ठीक है. So we are asked A, B, D, F, and E. Okay. And for that, we have, so we can write it like C, A, B, D, F, E, and we can put a proportionality constant for the denominator. We can do that, right? I'm just opening up the space. I can do this. Do you agree or not?
What?
Like I can write this as alpha times this. Can I write this or not?
Yes, yes, you can write.
You can write it. You're just taking alpha equals to 1.
No, no,
No,
no.
no,
So
it's for the
it
denominator.
will be one over the denominator, exactly. One over the denominator, right? So that is some normalization constant. Now
Okay,
what?
okay. No, fine,
Right?
fine.
Now you think of this now. So I can write it like D given C A B D given C A B E and F. Okay, D given C A B E and F, and P of A B C E and F. I can write it like this,
Okay,
right?
fine.
So this thing I can remove these. I can remove. So this will be alpha times P of D conditioned on C comma E. I can reduce this expression to C comma E. See, because if
Fine.
I have my Markov blanket, then I'm independent of all others. So Markov blanket of D is just C and E,
Okay.
right? And then I write P of C given A, B, E, and F times P of A, B, E, and F. Right? Now this probability I am pushing to alpha. Now let me push that probability to alpha.
How can you push that to alpha?
Right?
It is not
Because
normalizing constant.
it's a constant. Now I can ultimately whatever I
Well,
will get, I will normalize it.
okay, you're saying it is common to both C and complement to C, right?
It is
Yeah,
a
okay.
constant kind of setting. Na? So I can just write
Hmm.
alpha times P of D conditioned on C comma E and P of C conditioned on A, B,
Yeah, this works. This works.
right? So
You
then I
can
can,
just remove E and can you remove E? You can't remove E. You
so
can't
C,
remove E from
C
here.
is conditionally independent on E na, because I don't have D,
No,
right?
no, you can't remove E. It is
If I have evidence on D, then it is blocked, right?
but you are not saying that you have evidence of D. Nowhere it said. in this equation.
Information can flow between A and C if we do not have any information. कैसे तोड़ा है फिर इन्होंने? इसके अलावा और कैसे तोड़
No,
सकते
this doesn't work. This doesn't work.
हैं? It should be C condition on A, B, E, and F. So if I want to remove E, because you need to have the entire Markov blanket, na?
Yes, you can't just like take something out of Markov blanket. Those are like privilege variables.
But given my parents, I am independent of my non-descendants.
No, yeah, it's non-descendants.
And so
Given your
E is
parents,
not a non-descendant to me,
okay, given your parents, you are independent of non-descendant, and you are given AB.
right? So I'm
Oh,
independent
yeah,
of E,
okay, yeah, you're independent on ENFs, right, right.
right? So everybody followed this, right?
Yeah, fine, fine.
Okay. Okay. So yeah, I think there are only six. Two of me are okay. ठीक है.
Yeah, so I have a question. So this kind of problems, the like conditional dependence, independence, you will
हाँ.
mostly start with this approach of Markov blanket, is it? I mean, that is,
मतलब पहला first reference should be कि if you have a parent, if you have your parents, then you are independent of your non-descendants. That should be the first rule to apply. Then you think that okay, because you will not have a lot of evidence, right? You have to start with this idea that what kind of evidence do I have, right? Now in this case I have the evidence of my parents. My parents are AB and I know my parents, so then I am independent of my non-descendants. Now who are my non-descendants? ENF. So that's why I
ENF,
can
right?
remove ENF from here. That was my argument.
Given AB, right?
Yeah, given AB I can remove EF because I am independent of my non-descendants.
Hmm.
This was the first rule before Markov blanket.
Okay, X is independent of
Non-descendants, only non-descendants.
non-descendants. So Zs are basically
Hmm.
non-descendants, right?
Okay, cool. So
And
yeah,
and and what is the Markov blanket formula? Given
so
your Markov blanket, when
Markov blanket for C would be the parents of C, the children of C, and the parents of children of C. So here it is A and B are the parents, D is the children, and parent of D is E. So the Markov blanket is A, B, D, and E.
AB, D, and E. Okay.
Yeah,
Hmm.
this was there in the slide. Like if you see this slide, it is parent of X, union child of X, union parent of child of X.
Child survey. Okay. So F is not in the Markov blanket, right? Only A, B, C, D, and A, B,
F is
and
not
A,
in the
B.
Markov blanket exactly. F need not be in the Markov blanket. That's true.
Hmm.
So from this information, you got the option D directly.
C and D. That is
No,
what.
no, no. From this Marco blanket
From this
information,
Markov
you got
blanket
it D
funda, we got
directly.
option D. We got option D
Yeah.
directly.
Hmm.
Markov funda says कि if you know your parents and if you know your Markov blanket, it is independent of all the other nodes. In this case, F. So we can simply drop F. So we can
Yeah,
drop.
this is understood. But how did you break up this D given C comma E? Could you please just repeat it? I
Yeah.
didn't get it at that
So
point.
see, I just wrote this expression C given ABDFE as this. I can write this
Yes,
expression
yes,
as
right.
alpha
Right.
times this. So you followed this, right?
Mm-hmm.
Then I can break this expression using the structure of the Bayesian net as D conditioned on CABEF.
Yes, yes, that's correct.
Okay.
No, no, the way you have written P C, given A B D E, P of C given A B D E, then after that you just
Huh. So
elaborated.
see, from P, so from this we got P of D given CE, and from ABCEF I can write it again using the Markov structure P of C given ABEF. I can write like this. So this expression I can write like this expression. Do you agree with this or not? First
Here,
let me ask.
B given CE into
Should I write it once more clearly or
Okay, what's the Markov blanket of D? D is
uh,
C and E, and
C
so
and E?
thus we can ignore everything
Huh,
else.
huh, huh. So you can ignore ABF here. So D given C A B F E, the Markov blanket of D is just A and E. So these all can be dropped from here. You just need to consider C and E. So this part is rewritten as D given C comma E, and ABCEF is written as C conditioned ABEF into P of ABEF. Now I push this into the constant also. Let this be part of a constant, right? ABEF, let that be a part of constant. Then I wrote alpha times P of D given C comma E and C conditioned on ABEF. Then I argue that using the first rule, if I know the parents, I am independent of my non-descendants, which in this case is E and F. I can say that this expression simply reduces to P of C conditioned on A comma B. And I can remove EF because E and F are non-descendants to C, and C knows its parents A and B. So I can write it like this. Yes or no? Okay. Yeah, I think this was a pretty straightforward thing here that we did, which was also in the rules mentioned in the slides, that given parents X is independent of its non-descendants, and hence we finally landed with the expression P of C condition on A comma B into P of D condition on C comma E, and everything else is part of the normalization constraint. Okay, so with this, we will end today's session. And yeah, if you have any questions or anything, you can ask, or you can just leave. So, what is question 10? There's a question 10 also. Ah, yeah, which, which of the following options are correct about the environment of tic tac toe? It is fully observable and it is static.
Sir, in
Hello? Hello? I cannot hear you.
Yeah, we are not able to hear him.
hello.
Yes, you are now
Okay,
audible.
okay, okay, sir. So in the book, there is a table. Uh, there is a table which says that the image analysis is a semi-dynamic process.
ये क्या होता है भाई इतना तो मैंने पढ़ा भी नहीं. Let me see.
Sir, the professor discussed the static, dynamic, and semi-dynamic, right, in the lectures.
Mhm. Yeah, I did not watch the last lecture with full concentration because I felt
Okay.
like it is not linked to this week's topic. I don't know why it was taught, first of all, but it's fine. Yeah, so I can just open the book. We can just go over there. Which page?
Sir, it's
Actually, you
section
have a,
2.4,
you have a
structure of
different edition.
agent.
Na?
Section 2.4,
You can
structure of
just share
agent.
your screen. You can just share. You have a different book, right?
Okay,
You have
okay.
a different version. Huh.
Hello.
Yes, we can hear you.
Okay, so here the structure of agent. This says the image analysis is a semi-dynamic process.
The image analysis is a semi-dynamic process. Okay. So
So,
what's the
but this doesn't make sense because image analysis is of course a static process.
no? But what is image analysis? Have they explained anywhere? What is the
Image
task at hand?
analysis is image analysis. I think the professor says like something along the lines of like a distinguishing between the images of dogs and cats. Like this will be one example of an image analysis.
Where is that?
It was in the lectures. Professor gave an example like something like distinguishing between the images of dogs and cat, and he said that it is a static process, but the book says that the image analysis is a semi-dynamic process.
Image analysis is a semi-dynamic process. Maybe the
Like the, for example, the chess with clock is a semi-dynamic process because with time the clock ticks. So you
hmm,
can never have two state. You will never encounter the same state twice because with every passing clock, like the like if you have 5 second and one move, like one board state, you will never get to that same state anywhere, anywhere because you will never get 5 second your 5 seconds time because your time will always tick forward. So it's semi-dynamic. While the games like taxi driving is a dynamic process because you will never get the same set twice because of the sheer amount of search space. The process is a static process because you can like
वो ठीक
the
है. That is understood.
then image
But
analysis of course static process, right?
then you should also ask that poker, why poker is a static environment then?
Because poker the state always remains the same, like it doesn't changes with time. If you have five cards, like if like some uh, if you have like you can take your time, right? You'd never changes the state automatically. There's no some third party which can change your cards when you are like thinking. The professor said that in the semi-dynamic and dynamic process, it has become important to think about meta thinking, like how much you should think. And while in static process, it doesn't even matter how much you should think. You have infinite amount of time to think.
In semi-dynamic processes, what does the professor
In
quote?
semi-dynamic and dynamic process, you have to talk about meta thinking. How much do you think? For example, in chess, you can't spend infinite amount of time
Just
in one move
like that. So is it for image analysis? Isn't that the case? So you have to spend time
because you
for
have infinite
thinking
time,
about it.
right? You have infinite time in image analysis. If you have to distinguish between cats and dogs, you have infinite time. There's nothing, no clock ticking.
No, but that you are only saying from the perspective of chess with a clock. So
Yeah, normal
what
chess
does a
is
semi?
not
So can you just go to the actual definition of semi-dynamic? So
okay.
there should be a
Semi-dynamic
definition, right?
controller, semi. Yeah, okay.
What does the book says about semi-dynamic?
Okay. It was here. Just
Yeah.
I messed it up. The fuck? How is it going from here to here? Page 42. Yeah, here, here. If the environment itself does not change with the passage of time, but the agent's performance score does, then we
Yes,
say the
that
environment
happens.
is
No?
semi-dynamic.
When you do image analysis, your accuracy improves with time.
No, no, but it improves when I make an action, right?
And it says if the environment itself does not change with the passage of time, but the agent's performance score does.
But
And
when I'm
when
trying to analyze an image, I don't have any time constraint. I have infinite time, right?
so let the time be infinite. You read the full sentence. What does it says when it means what does it mean by semi-dynamic? See, the environment is not changing. The environment is just that you have a collection of images. That is your environment, right? The images are not changing, but the agent's ability to identify dog from a cat, that changes with time, right? Its performance improves as it sees more images.
But that is true for all everything, even checks without a clock. Without a clock, the ability of agent will improve. Like even the crossword puzzle, as the agent will try to play more and more crossword puzzle, its ability to play crossword puzzle will improve.
Now then,
That's by
what is
that
the difference
definition.
between semi and static? So then check the definition of static. What does static means then?
Static means here, if the environment can change while the agent is deliberating, then we say the environment is dynamic for the agent.
Yeah, so
Otherwise, it is
it does not depends on time, right? Static environments does not change. So the
yeah.
environment is that you are just playing chess. That is the environment. So your environment is bored.
And image analysis, we have the environment is the picture. The picture does not change unless when I am thinking, right?
See, static environments are easy to deal with because the agent need not to keep looking at the world while it is deciding on an action, nor it need to worry about the passage of time. But when the in the chess with the clock, you do need to worry about the passage of time, right? because if time has passed and you have not made a move, you will definitely fail.
Yeah.
Dynamic environment, on the other hands, are asking the agent what it wants to do, right? So, for example, in case of
Image analysis.
image analysis, the environment is not changing, but the agent's performance is changing. That's why it is
Yeah, but
writing
agent's
it as
performance changes everywhere, right? Agent's performance will change in crossword puzzles as well.
no
Like
in
I don't think the
crossword puzzle. How uh, how will you change the agent's performance?
as we are changing in the image analysis performance,
No, no. See,
the
in
agent
image
will learn
analysis,
about the images the same way the agent will learn about the
in
crossword puzzle.
crossword puzzle, what you do, see, in crossword puzzle, what you do, you give it. So, in crossword puzzle, you are given like some uh, what is it? So you have above and across, like above, below, across, and so those sort of things are fixed, right? But in image analysis, you try to grade the agent's performance in terms of some metric like accuracy, F1 score, and that increases with time. Although the environment, that is the set of images, they don't change, but the ability to identify a cat from a dog, that changes drastically if you train it for infinite time, for that matter. So one thing that I find hard to follow is what how are you distinguishing these environments? So if, can you go back to the book? Like maybe we can see it there. If you just go back to the book, just pull up the definition of static, dynamic, and semi-dynamic, where it is defining. Yeah. It is saying if the environment can change while an agent is deliberating, then we say that the environment is dynamic for the agent, otherwise it is static. And how do they define an environment? So what is the definition of an environment
So
according to the book?
environment is anything which the agent does not have a complete control of.
Environment is, so
Anything for which the agent does not have any
it will
complete
be a
control
formal.
of.
Let's look at the formal definition. I think there should be a definition above somewhere, right? If you just scroll up, there you will find something.
Nothing.
So can you just scroll up? Like if you scroll up or something, like
Nothing. I don't think they are giving definition of environment.
online search. So I think environment is like entire world. Let's just,
No, I don't. The environment is not entire world. The environment is anything for which the agent does not have a control of.
or it is the uh, so then in chess, what is the environment?
Environment is the board, the time, and the opponent.
I think there was some bulleted point somewhere. The task environment specification includes the performance measure, the external, the external input that itself has an environment in it.
This does not make help.
Let's just first clarify what does an environment mean. If we,
I'm pretty sure the environment, because in other books too, this definition is used, right? I've read some books on reinforcement learning, and where they explicitly define environment to be like a model where like the agent does not have a complete control of anything is the environment. I can't move to the first, right? There's no option to do that. The agent itself is does not considered in the environment.
No, no. So I googled it and I saw that an environment in artificial intelligence is the surrounding of an agent, and it is where the agent operates.
Yeah.
ठीक है. तो a chessboard,
The agent itself is not considered an environment.
and is where the agent operates. That is what it is saying.
Yeah, it's the where agent operates, not the agent itself.
I'm not
Like you're
saying
saying,
that.
like the agent will like learn, then that is not part of the environment.
Hmm. So when we are saying an environment that keeps constantly changing itself, when the agent is up with some action is said to be dynamic. So in case of chessboard, the dynamic part is added by the clock.
Clock, not the board.
वो ठीक है, not the board. A roller coaster ride is dynamic as it is set in an ideal environment with no change in it is called a static environment. And you are saying that the image classification is a semi
No,
dynamic thing.
I'm saying that image classification is static. The book is saying it's semi-dynamic.
An ideal environment with no change in its state is called a static environment. An empty house is static as there is no change in the surrounding when an agent enter. In a no output तो ठीक है. तो image classification में see the point that made me to class characterize it as a semi-dynamic would be that the agent's performance metric that changes with time.
Yeah, but the performance metric is not considered in the environment. I don't think so. Like because the performance metric is influenced by the agent. Like
That
the reason is the agent itself, and the agent itself is not the part of the environment, so it doesn't count. Like any agent that will as he starts learning the environment, he will improve on it, and that way that nothing is
those
stuck.
are the funda of RL. वो तो RL का फंडा है.
And then by that definition, nothing is static or dynamic. It doesn't even make sense to talk about
So
static dynamic.
why have they put that part? See, in static and dynamic, what I am seeing what I am seeing on the website is that if it is static, then the environment does not change. Whereas if it is dynamic, the environment changes. It keeps constantly changing itself when the agent is up with some action. Then it is a dynamic environment. ठीक है? So in image analysis, does the environment so have they defined the task of image analysis? Or
No, they didn't define it. Uh,
so can you just search for image analysis? Because if they have described image analysis somewhere,
no, they did not. The image word itself is only comes once
no,
in the book.
it comes four times.
Okay, these are after it has already been there, right? These are the
Oh,
like it doesn't matter like what after comes. It matters what before comes. Okay, okay, it here. Yeah. Image understanding, not containing or exceeding. If there's a computer vision. Image captioning, some a person writing it. This was not image.
because if we are clear about that part, only then we can make a proper comment like what is the task at hand? Is it just classifying cat or dog, or is it like analyzing satellite changes in the satellite images,
Yeah,
or it's
that would be video recognition, video analysis, right? Image analysis is static, video analysis is dynamic. If you're talking about video, it's dynamic,
no? But
but
there was
image
this
not.
one, no, there was this one example. If you scroll up, I saw that there was some satellite thing or something which they were talking somewhere. Is it that imaging, satellite imaging analysis?
Even if it's like one,
Because
then
if it
that
is
will be
satellite
video.
imaging, then you can clearly see that it is a
Like then
dynamic
it's
image.
video. Like if it's the video of a satellite, then it's dynamic. If it's the image of a satellite, it's static.
सेमी डायनामिक क्या होता है बीच की क्लास कहाँ से आ गई
No, I don't see any satellites here.
so semi dynamic means that the environment is static
No, no, the semi-dynamic environment is just barely dynamic. Like the chess with a clock, the only thing dynamic about chess with the clock is the clock. The state does not change.
So semi-dynamic environments are environments that do not change with time.
Hmm. That changes with time.
No, semi-dynamic mean environment does not change with time.
No, yeah, environment does not change, but the time itself changes. Time is a significant factor.
So just with the clock, image analysis system. So according to download ये क्या है?
If he means like if the image analysis like yeah, maybe it doesn't like yeah, no point, like it's already 9 o'clock, I need to go to sleep. Yeah, let's we will discuss later. Yeah.
Hmm. Environments and problems. ठीक है, I think we can, but yeah, if the point is that the definition of semi-dynamic environment, it says that the environment does not change, but the performance metric changes, right? That is what it is saying.
Hmm.
So I think that might be just that with image analysis systems, the performance of agent changes might change drastically or something like. But that would be true for any RL environment. Then how is it differentiating? That is not clear to me. The environment is deterministic if the next state of environment is solely determined by the current state. This environment appear to have non-deterministic state. Episodic, non-episodic state environment if it changes. An environment is semi-dynamic. So what is the difference? An environment is dynamic. Achal, see, just let me resume my presentation. Just read this part. I think it is taken from the book itself. It is saying that an environment is dynamic if it changes while an agent is in the process of responding to a perceived sequence. It is static if it does not change while the agent is deciding on action, that is, agent does not to keep in touch with time. An environment is semi-dynamic if it does not change with time, but the agent's performance score does. So
I
in
think
case
it has something to do with like if the particular agent is penalized for like taking 2 hours to analyze an image, then it's semi-dynamic, something along those lines.
performance score on what? Say this again is a very vague statement.
Like
Performance
this is
score.
like performance scores straight out of RL terminology. This is the reward.
हाँ वही ना कि if you are guessing it right,
Yeah,
then you
if
get a
the
reward,
whatever
and
the reward, if the reward itself is dependent on time, it's semi-dynamic. Like so, in this case, if the like classifying the images of dogs and cats, like if you put a clock on the table, like you have to classify it in 5 seconds or something, then it's